What's up, Andrew? Renewed awareness. Yeah, I would have had a conversation already, but I was still setting up the cameras and everything. So I would have literally had to stop doing that to start the presentation, right? Which I could have, I guess, but I would have missed that whole first conversation with it. But again, I wanted to be set up first before anything. It is what it is. What's that? You guys want to give us a shot real quick? Two very easy questions, multiple choice to see if you guys can get them. So here I have 3 box trucks. They're all on a level surface, they're all completely sealed, and they all have an apple hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which truck is at rest? You guys got it? How do you guys know it would be?
Because it's still, like, there's nothing, like, there's no, like, there's no force.
There's no motion, exactly. Which one's accelerating forward? Yes, how do you guys know it was it?
Because the force of the air is pushing back.
Well, not necessarily.
Well, it's just like, I don't know what it was. Honestly, I don't know how to explain it to you. It's
Yeah,
just
the
like
app was...
a string.
Yeah, so the app was remaining in its position in space
Yeah.
due to inertia, and the truck's moving forward. So the app was just being left behind, pretty much. But you guys got it. I mean, you guys understood it. Pretty easy, right? The second one is pretty similar, but instead of an apple inside, it's a helium balloon inside the truck now. So out of these 3, which one is at rest? Yes, and it's for the same reason as the first, because there's no motion. which one is accelerating forward? Actually, I'll help you guys out a little bit with this one. So this is a buoyant object, right? The helium balloon, because it floats. This is also a buoyant object because it's floating in water. So this ball represents the balloon. Right now it's at rest, so it's obviously vertical, but I'm gonna accelerate it this way and see where the direction of the ball goes. You guys see? Yeah, one's cool. Yeah, so out of these three, which one's accelerating forward? It is C. Yeah, so there's two reasons why that happens. You guys happen to know why? What are the two reasons?
Maybe like the fact that it's like the helium, maybe it's like lighter or like.
Yes, so there's a density difference. So the helium is less dense than air. That's the first reason. What's the second reason?
Can you get like a hint?
So it has to do with a force.
A force.
Yeah, so it actually is a force. So as soon as I apply the force in this direction, all of the air that's inside of the truck is also being forced in that same direction through space, and because air is more dense than helium, he's able to push it along with it. The apple is more dense than the air, so the air can't push the apple. So the apple just gets left behind. Yes, exactly. So look, I recreated this experiment inside of a cargo van in real life. So it's basically both questions in one. There's a helium balloon and an apple. So based on the principles of how matter behaves, what direction did I accelerate this van? To the right or to the left? To the right, exactly, because that's the direction that the air was forced and the helium was also forced in that same direction. Again, the apple just got left behind. So here's a bonus question. It looks like the apple and the helium balloon are moving away from each other. That's what it looks like when you're inside. But in reality, only one is moving away from the other. So out of the helium balloon and the apple, which one is moving away from the other?
They're moving away from the other?
Yeah, only one is moving away from the other. They're not moving away from each other. It looks like they are, though, when you're inside the container.
I want to say the helium balloon.
Yes.
Because
yeah, the balloon is being forced forward, but the apple's being left behind. So the balloon only moved away from the apple. Exactly. You guys got it. Okay, one last question before you guys go. If I have a helium balloon and an apple here on Earth, and I release them both, we can see that the helium balloon goes up and the apple goes down, right? So it looks like they're moving away from each other as well. But in reality, only one is moving away from the other. So out of the apple and the helium balloon here on Earth, which one is being forced away from the other, in other words?
I think the apple is being forced because...
So, no, the reality is the helium balloon being forced up away from the apple. No, but here's the reason why. I don't know if you guys knew gravity as a pulling force is just a theory. So it has never been proven or detected or measured. So in other words, it doesn't exist. That's because the fact is the force of the Earth is not a downwards pull, it's an upwards push. So the Earth is literally pushing up against your feet right now, not pulling you down towards it. And that upwards, that upwards push is pushing up the air, which is creating the air pressure. And that's why air is able to push up helium balloons. So the apple only gets left behind and the Earth crashes into the apple.
That's really interesting.
Yeah, so the Earth is literally moving up like a giant elevator right now. So here's the real reason why I'm doing this. You guys believe the Earth is a ball, right?
Yeah.
So you guys understand that on a ball, up is relative. So if you're standing here, up is this way, but if you're standing down here, up is this way in the opposite direction. Every direction away from the center is up. If we could prove physically that the force of the Earth is an upwards push and not a downwards pull, how can the Earth push up in every direction at the same time if it was a ball? So what would happen to the Earth if it was moving up and if it was a ball as well?
It would just stay still.
Well, that means it wouldn't move up.
Yeah.
But the fact is, in order for the Earth to move up as a ball, it would have to be expanding to be able to push up equally in all directions at the same time, which obviously wouldn't work. The Earth would just explode. So that would be the number one proof to debunk the ball Earth, is the fact that gravity is an upwards push of the Earth, not a downwards pull. So what does that mean? That means that the Earth is just an extended level plane and is only pushing up in one direction. So everybody's up is the same. Everybody's standing on the same level. So Australia and China are not bending down under your feet. Everything is just across the way. So again, that would be the number one proof to debunk the globe Earth. So if I was to ask you guys respectfully, why do you guys believe the Earth is a ball?
I just feel like there's been a lot of stuff put out there to like claim it's a ball, and I feel like there's been stuff put out, like for example, I've seen like images or like videos of like people with like not images, sorry, like video or like
video, sure.
Studies about like they have like a camera and they put out a bunch of like little holes across the Earth, which are like enough distance to like prove a curve or something.
Okay, so like a laser experiment over the Earth to show that there's curvature. Okay, so I'm gonna show how that's a faulty experiment.
Yeah.
So if I was to shine a laser through water, will the laser go straight?
I don't believe so.
No, exactly, because of refraction.
Yeah.
Exactly. So the moisture here on Earth, the air, the atmosphere, is going to refract any lasers shining through it. So you're always going to have an inconclusive answer because the laser is never going to go straight regardless.
Yeah.
So there is a better experiment to measure for curvature that will debunk that there is no curvature. So do you guys happen to know the radius of the Earth by any chance?
Yeah.
So that way we know how much curvature there should be, right, to measure for that. So they tell us that the radius of the Earth is 3,959 miles. And they have to give us this number because they're supposedly having satellites orbiting the Earth. So they need to know the radius of orbit. So they need to know the radius of the Earth, you know, if they're claiming it, right? So it is 3,959 miles. So based on the radius they're giving us and using a calculation like the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile. And it turns out that there should be 8 inches per mile squared. What that means, in the first mile, there should be an 8-inch curve. Second mile, there should be 32 inches. And by the third mile, there should be 6 feet of curvature. And 10 miles, there should be 66 feet of curvature. So how do we measure for that curve, right? To know if it's actually there or not. So very easy. If we went out to a giant lake that was 3 miles across or even 10 miles across, filled with water, and we build a level structure above that body of water, when the water's at rest, the water's going to be parallel to anything horizontal above it because that's what water does. It takes the shape of the container, but the surface always collapses to form a level, which is horizontal. They're trying to tell us that every lake on Earth is bending 8 inches per mile squared, which is 6 feet and 3 miles, which is a physical impossibility for the surface of water to bend, especially on a lake, because that's the physics of water when at rest here on Earth.
But you have to account for the fact that the gravitational pull of the moon is kind of what causes tides. You have to understand the tidal movements, though.
Yeah, well, again, the gravitational pull of the moon is a theory based on the gravitational pull of gravity, but the upwards push of the Earth is the true force.
Then how would you describe
Tides?
the oceans?
Yes, so I'm glad you brought that up. So the tides, here's what's happening with the tides in my opinion. Let me show you. So water, again, water's perpendicular to the vertical force of the Earth, right? But it's an upwards push, not a downwards pull. So in other words, if we add a horizontal acceleration to water, the water deviates. In other words, if we change the vector of the water deviates to accommodate that vector. That's what happens to water, it displaces, right? So in my opinion, the tides, I'm glad you brought them up. Okay, so the tides, again, the tides, obviously we understand that there's different tides on Earth. Some places have like 10 feet of differences in tide. Some places have like 40 feet. So it's not a constant. So there's a difference in height. So based on the tides, this is what the water's actually doing. It's not doing this because the Earth is not a ball. So this tells me that there's a change in the Earth's motion vector. So it just simply means that the Earth is not moving in a perfectly straight line up. There's a slight deviation of the Earth's upwards motion. And that's why we have the tides, because the water's reorientating to the vertical force of the Earth. And that's why even the mainstream definition of the tides is the difference, you know, it's a horizontal movement of water. It's the difference in height, you know, of water change. There's a change in the ocean's water, obviously. But again, it's not because of the gravitational pull of the Earth, it's because there's a slight deviation in the upwards push of the Earth. You know, that's because there's a change in the vector. So this is what the tides are doing, you know, not this. You know, so what do you think about that?
Then how would you explain like it's like time zones and like why places get sun and why don't?
Yes. So time zones. The reason why we have time zones is because the sun is not 93 million miles away, like they tell us, and much bigger than the Earth. You know, like 400 times bigger than the fact is the Earth is within our atmosphere and it's very tiny in comparison to the Earth. So the sun just simply moves around above the Earth.
Yeah.
And wherever the sun is right above you, that's where it's noon for you. So the time zones is based on the motion of the sun above us. Yeah. So the sun gets to New York first, it's noon for them, and then it comes to us, and then it's noon for us. So there's a difference in time between here and New York because the sun, it takes time for the sun to travel above the Earth.
And then like would that like also apply to the moon? Like
yes, the moon, exactly. So the sun and the moon, I would say they're just opposites. Another thing about the moon, which has nothing to do with the shape of the Earth, is that the moon emits a cold light. And people have done tests. I haven't done it myself, but if you put a thermometer in direct moonlight and then in the shade, it's going to be colder in direct moonlight than in the shade. So it just shows that there's the moonlight is a cold light and the sun is obviously a warm light. So they're kind of opposites in my opinion, like the yin yang in my opinion. Yeah.
Is this a religious thing or?
No, this has to do with physics, nothing to do with religion. I'm actually not religious at all, but the ironic thing is I used to be atheist. which ironically is the biggest religion on earth. Why? Because atheism goes on the belief that everything came from nothing, which is a belief. Again, at the end of the day, all religions are based on belief. The fact is, the earth is a creation. Why? Because the first law of thermodynamics shows that something can't come from nothing. It can only one thing can only transform from one thing to another. So this reality didn't come from nothing. They try to tell us that the Big Bang obviously was nothing and then exploded and everything into existence, which is just a religion. So the fact is, this is a creation, but nobody knows how it was created. So every religion is going to try to tell you how it was created because they're trying to control people. The fact is, I acknowledge that it is a creation, but I don't know what that creator is and how it was created. You know, that's just the fact. You know, that's the reality. So I know you mentioned videos from outer space, right, and images. So if I showed you guys a video or an image of me flying, would you guys believe I could fly?
No.
No, obviously. Why wouldn't you guys believe me though?
Just because I feel like that's like very, it's just not very credible.
Exactly. I would say it defies physics. So any claim that you make to me that defies physics, I automatically know it's bullshit. Like if you told me that you couldn't walk through walls, and that defies physics. Obviously, you can't walk through walls, right? So the globe Earth defies physics as well. So all the images and videos they're showing us from outer space, they're actually all CGI and done with blue screens and green screens and augmented reality as well. I don't know
why do you think this is like a thing? Like, if you have an opinion, like, or like, why do you think that they would do that? If taking into account your opinion, like that it's not round.
Yes.
Why would they like say that it is?
Okay, so one, obviously they're trying to hide that this place is a creation and there's purpose to our existence. Second, in my opinion, is they're doing it so that we don't have our own critical thinking skills and we just obey authority over our own common sense. So that basically doing it to dumb us down so that we're more easily controllable. So believing in the globe Earth, I know it might sound a little far-fetched, but it's no different than believing in Santa Claus. Because Santa Claus is just a belief, it's a story that defies physics as well, obviously. But the globe Earth is no different. So if you believe in the globe Earth, that just shows that you haven't critically developed your mind to be able to be an independent critical thinker. So you're gonna be more easily controllable. So it's about control at the end of the day. It's about control. So
who do you think is like above?
So the government, there's a shadow government in my opinion. So there's people pulling the strings behind the government. The government are just the face that they show us that that's who's in charge. But in reality, the presidents, governors, all of these representatives, they're just puppets. So the real people that are in charge, pushing this agenda to control the entire humanity, I don't know who they are.
I've never like applied it to this specifically, but I've always believed that they're like our politicians and anything else. It's not really them, it's people with like more power behind them, funding them.
Exactly.
I've always believed that, but again, it's just so hard to determine where that's coming from.
Exactly.
Who really has power.
They definitely hide behind all of these characters in front of them. So I know a lot of people might say, oh, they're doing it for money, which again, at the end of the day, NASA does take a lot of money just to show us cartoons on the TV. But the reality is money is just a tool that they're using to control us, because at the end of the day, it's not about money, it's about controlling resources and controlling the land. Because that's how they're able to control our lives. You know, if they control the land, then they're able to sell it back to us. And I hate to say it, but we're kind of dumb enough to just buy into it because we don't have our own critical thinking skills, and we just pay a bunch of rent, a bunch of mortgage that nobody should be paying at the end of the day. You know, the land's already here, regardless whether we pay or not. It's going to exist regardless. The land was here before us. So, again, if anybody's going to have the right to charge rent or mortgage, it's going to be God. You know, because he was the creator of this place. Whatever that God is. Again, I don't buy into any religion. But, again, it's a power grab, you know, at the end of the day. Interesting. So, let me ask you guys this. Do you think it's possible that we have been lied to about the nature of the Earth and our existence? Or are you guys 100% convinced that it is a ball?
I'd say I'm still convinced that it is. I would say that like still like I'm gonna like if I had to tell somebody what I believe, I would say I'd still believe it's a ball.
Right.
Only because this was very short and like I would have to look into it more on my own.
Yeah, definitely.
But I'd say definitely now I'd say more skeptical. However, like I would still sway towards like believing it's a ball. Fair
enough. I like your honesty, but let me ask you this: besides images, because we know images can be doctored easily, especially with the technology nowadays. Other than images, what else? Obviously, because of that experiment you said, the laser experiment, obviously it's a faulty experiment as well. And obviously this will be a better experiment, a physical structure above the Earth, like a giant ruler, to show if the Earth truly deviates away from the ruler. If it's a ball, I should. But other than that, like, is there anything else that makes you believe in the Earth being a ball?
I'm sure there's been like other things throughout my life which have like I've seen or like I've heard of
Okay,
to like
fair
debunk
enough.
the sort of flat Earth. There's nothing that comes to mind right now though.
Okay.
It's kind of just like you said, it kind of has just been like a sad belief in my mind.
Fair enough.
That,
It is a belief.
that it's-
And what about you?
Nothing's changed there.
Why do you believe the Earth is a ball, though? Well, what's the one thing that just keeps you like it has to be a ball or it is a ball?
It doesn't affect me with this stuff.
No, I know it doesn't affect you, but would you say you just believe it because that's what you were told? Fair enough, right? Now, let's say we were being lied to. Would you want to know the truth, or were you okay with just being ignorant?
I'm okay.
You're okay with being ignorant. It doesn't change your life, really, right? That's fine.
It'd be a bigger change if it was. I'm happy with where I'm at.
Fair enough. Fair enough. I mean, do you guys have any questions for me about this subject?
Or where did you like come about with all this?
Yeah. So ironically, I was a huge fan about outer space and aliens. So I would fantasize about other planets and all that stuff, right? So I didn't want the Earth not to be a ball. You know, honestly, I looked into this subject 10 years ago to try to debunk, you know, the flat Earth, right?
Yeah.
But the opposite happened. The globe Earth got debunked.
Yeah.
And I found out later that even the flat Earth is controlled. Why? Because even flat earthers, a mainstream flat Earth that's being pushed on everyone as well, they also claim that there is something pulling objects to the ground, forcing objects to the ground.
Yeah.
Why? Because they believe the Earth is motionless. So they denied the upwards push of the Earth, which is clearly evident because buoyancy shows that there's an upwards push, because buoyancy is a force, it's an upwards push of the Earth. So motionless flat earthers deny that fact because that's the number one proof that debunks the globe. So they're the controlled opposition. So the globe Earth versus flat Earth is no different than Democrats versus Republicans. They're both being controlled by the same entity, by the same people. So it's just a pointless debate that's happening right now. So the reality, again, is the upwards push of the Earth that destroys the heliocentric model. Because the whole heliocentric model requires a pulling force of gravity to explain the whole model. That's how they explain Earth being a ball. That's how they explain orbits. That's how they explain water sticking to the ball while it's spinning. That's how they explain the atmosphere getting stuck to the Earth and it doesn't disperse into space, because air pressure requires physical containment. So the Earth is a contained system, a physically contained system, and we're inside of it. We've never been outside of it. But they claim that Earth is an open system, that outer space is just, right next to the Earth atmosphere. And somehow the air doesn't escape into space because the pulling force of gravity. Again, a theory to explain away all these anomalies that defy physics. So again, the whole flat Earth that they're pushing online is there to just defend the globe, to defend this idea that there is objects accelerating down in free fall, but in reality there's not. It's the upwards push of the Earth, and anything that's in free fall only appears to go down because it's actually the Earth that crashes into everything in free fall. Because the Earth is literally constantly moving up like an elevator, and that's why we're stuck to it, because it's constantly pushing up against our feet.
Yeah.
Yeah.
How are you fund, or like all this, is this like all like self-funded?
Yes, I do this out of my free time, and actually it costs me money to come out here, so I have to take a day off work because I have a full-time job. You know, I don't get paid for this. So yeah, I come out, I set up myself, and I do this on my own.
That's cool.
Yeah, I appreciate that, man. Yeah, this is the #1 censored subject online by far, which is another reason why I decided to come out. So you're never gonna see any genuine people online. It's gonna be hard to really come across the algorithm. Are not gonna push people like myself. Like my channel is super censored. It's never gonna get recommended to new people. So the only way to reach new people is by literally coming out in the real world and speaking to people like yourselves. That's the only way this is gonna move forward. Yeah. So all the people that will get recommended to you are gonna be these motionless flat earthers, which again they're bullshit. So at the end of the day, it's about thinking for yourself. And coming to your own conclusion based on the facts. So again, this has to do with physics at the end of the day. Physics doesn't lie, men do. At the end of the day. So again, any other questions before you guys go? No, I appreciate that. So here, let me give you guys my channel. I go to all the major universities here in Southern California, and you guys can check me out. All right, perfect. I appreciate the chat, man. Yeah, take care.
Have a good day.
Yeah, you too. Hey, what's up, man? You want to give this a shot?
Yeah.
All right, let's do it. So it's 2 very easy questions just to see if you're smarter than a 5th grader. They're multiple choice. So here's the first question. There's 3 box trucks. They're completely sealed. They're all on a level surface, and they all have an apple inside hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3 box trucks, which one is at rest? Yes, you got it. How'd you know it was B?
Because like when you move, then the apple backwards.
Well, it gets left behind.
He's left behind.
Yes, exactly. It looks like it moves back, but because it's the truck that's moving forward. You know, but yeah, you got it. Which one is accelerating forward? Yes. Yeah. And how'd you know that?
Because the apple gets left behind.
Exactly. Yeah. You got it. Perfect. All right. So the second one. What's right here? Here we go. It's pretty similar, but instead of an apple, it's a helium balloon inside now. So out of these three, which one is at rest? Yes, and it's for the same reason as the first, because there's no motion. Exactly. Which one is accelerating forward?
One that's accelerating forward would be this one also.
Okay, let me help you out with this one a little bit. So the helium balloon is buoyant because it floats in air. This is also a buoyant object because it's floating in water, right? So this ball represents the balloon. So right now it's at rest, so it's vertical, there's no motion. But I'm gonna accelerating in this direction, and I want you to pay attention what direction the ball goes. All right? Did you see what happened? So based on that, what direction, which one's accelerating? It is C, yes. Now there's two reasons why that happens. Do you happen to know why?
No.
So the first reason is that air is more dense than helium in this scenario. So there's a density difference between the air and the helium balloon. The second reason is a force. So whatever direction I apply a force, like if I apply a force in this direction, all of the air that's inside the truck is also gonna be forced in that same direction through space, and because air is more dense than helium, it's able to push it along with it. So the air is not dense enough to push the apple because the apple is more dense than the air, so the apple just gets left behind. So that's the reason why the balloon gets pushed forward, because it's less dense than the air, and it follows the direction of the force. You know. So you guys want to jump in this?
Yeah.
Okay, let me just do the first question with them real quick, so you guys could be on the same page. So, all right, real quick, the first question again. So here I have 3 box trucks. They're completely sealed, they're all on a level surface, and they all have an apple hanging from a string. So inside. So the only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which box truck is at rest?
This one?
Yes, you got it. How'd you know it was that one?
Because it's still.
It's not moving,
so, yeah,
exactly.
It's not moving, yeah.
So what box truck is accelerating forward? Which box truck?
This one?
Yes. How'd you guys know it was A?
Because going back and like, isn't it like the first law, like Newton's law?
Yeah,
Yeah,
an object at rest will stay at rest
Yeah.
unless there's a force acting on it. So when the truck accelerates forward due to inertia, the apple just stays in its
inertia.
position. So the apple is moving towards, the truck is moving towards the apple. The apple just gets left behind. All right, you got it. All right, so the second one is pretty similar, but instead of an apple, it's a helium balloon inside now. So out of these 3, which box truck is at rest? It is B, and it's for the same reason as the first, because there's no motion. Which box truck is accelerating forward? Okay, let me help you guys out again with this one. So, helium balloon is buoyant because it floats in air. This ball is also buoyant because it's floating in water. So this ball represents the balloon. So right now it's at rest, so it's obviously vertical, but I'm gonna accelerate it in that direction. I want you to pay attention what direction the ball goes. So if you want to step back a little bit so you can see it. Look. Yeah, so out of these 3, which one's accelerating forward? C. It is C. So there is 2 reasons why it's C. Do you guys happen to know why? Yes, that's the first reason, because there's a density difference. The helium balloon is less dense than the air. What's the second reason?
I don't know.
Right, you need a force. So you need something to push the balloon. So when I applied a force in this direction, all of the air that's inside the truck as well is being forced or pushed in that same direction. And because air is more dense than helium, is able to push the helium balloon with it. So the apple, the apple is more dense than the air, so the air cannot push the apple. Yeah.
Okay.
Perfect. You guys got it. All right. So now we're on the same page now. So I recreated this experiment inside of a cargo van with a helium balloon and an apple in real life. So
That's so cool.
yeah. So what direction did I accelerate this van?
You go forward.
Yes, I did go forward because that's that's the direction the air was being forced, and that's the direction the balloon got forced. All right, here's a bonus question. It looks like the balloon and the apple are moving away from each other. That's what it looks like. But in reality, only one is being forced away from the other. So out of the helium balloon and the apple, which one is being forced away from the other? It's the balloon. Yeah, the balloon is being moved away from the apple because the apple is just staying in its position due to inertia. So only when you're inside the container, it looks like they move away from each other. But again, the force is only forward in the direction of the balloon. Okay, one last question before you guys go. If I have a helium balloon and an apple here on Earth and I release them both, we can see that the helium balloon goes up and the apple goes down, right? So it looks like they move away from each other as well. But in reality, only one is being forced away from the other. So out of the helium balloon and the apple here on Earth, which one is moving away from the other?
The balloon's going up, and
Yes.
then the apple's getting pulled down.
So you're saying they're moving away from each other?
I mean,
No.
It's not a trick question.
Yeah.
You guys believe that, but it's not a trick question. The fact is the balloon moving away from the apple. How do we know that? Did you guys know, I don't know if you guys knew this, gravity as a pulling force is just a theory. In other words, a downwards force has never been measured or detected. That's why it's just a theory. In other words, it doesn't exist. The fact is the force of the Earth is not a downwards pull, it's an upwards push of the Earth. So the Earth is pushing up against your feet right now. Yes, and not pulling you down. So the upwards push of the Earth is what's pushing up the air, creating the air pressure, and that's why air is able to push up helium balloons. So the apple only gets left behind. So the Earth is literally moving up like an elevator right now. And an apple, again, only gets left behind, and the Earth crashes into the apple. So, yeah, that's the reality. That's based on physics. So this is the real reason why I'm doing this. You guys all believe the Earth is a ball, right? Do you guys understand that on a ball, up is relative? So if you're standing here, up is this way, but if you're standing down here, up is this way. In every direction away from the center is up on a ball, right? If we could prove physically that the force of the Earth is not a downwards pull, but it's an upwards push of the Earth, how can the Earth push up in every direction at the same time if it was a ball?
Are you saying the Earth is flat?
I'm getting there, but it's not flat. But how can the Earth push up in every direction at the same time if it was a ball? How can there be an upwards force if the Earth was a ball? No, the magnetic field doesn't affect all matter. It only affects metal. Yeah. So that would mean the Earth will have to be expanding to be able to push up in every direction. So
isn't the universe like expanding?
they say the universe is expanding, but they don't say the Earth is expanding. They don't say the Earth is growing by the second, right?
Yeah.
That would mean the Earth would just explode anyway.
Right.
Because if it just kept expanding or just explode, it wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in gravity being a pull of the Earth. Because if we could prove that it's an upwards push, the whole heliocentric model falls apart. It wouldn't work. So the fact is the Earth is just an extended level plane that's pushing up in one direction. Again, it's not flat, it's level. And the difference is that flat, again, flat is not an orientation because you could have a flat wall. That doesn't mean the wall is level. The Earth is level because there's a force being applied. It's level perpendicular to the vertical force, which is up. So again, the Earth is just, we're all on the same level. In other words, China and Australia are not bending down under your feet.
No, yeah.
All the continents are just across the way.
Yeah.
Yeah, so that's the reality.
Are you saying it's not a sphere?
It's not a sphere 100%. It's just a level plane, a horizontal plane.
So then what about all like the other like planets and like the
What
sun?
about 'em?
Why are they spheres?
So they're not spheres. They show you CGI spheres on a computer screen, but this is what the stars actually look like when you zoom in with a powerful zoom camera. They're just lights that twinkle in the sky.
It's like a circle to me.
Well, they're just light though at the end of the day, you know. And here's another thing.
Yeah.
Here's
But
another
if you
thing.
look from space, doesn't it bend?
Yeah, can't you see the curvature of the Earth from like the ocean?
Wait, I have a question.
Yeah, wait, okay, we'll get to that.
I thought you were waiting.
Yeah, you have a question, you said? Okay, so you're saying you can see the curvature from where?
From like, if you look out from like the coast, can't you
Yeah.
see like the curvature of the Earth? Or like, if you
Oh,
see,
are you saying because you can't see past the horizon? It's like things disappear over the horizon, would you say? And that's the curve of the Earth, like the hump. Okay, so here's the thing. We don't have infinite vision, so there is a limit to perspective. So everything shrinks to a point until it's no longer visible. So what happens is if something reaches the horizon and it goes beyond that, it's just going out of our field of view.
Wait.
So the horizon is simply our field of view and our limit of perspective. But yeah.
If the horizon is our field of view, then how come we can see things that are like farther away? Like you could see like a mountain, right?
Yes,
For
that's-
example, but like
yes.
you can't see like
A
and,
house?
You can see like you can't. Like I can see
Statue
a
of
house
Liberty?
from like farther away, right? From like very very far away, right? And
I
when
mean,
I'm-
there's a limit to that
it's
too,
like the
though.
field of, yeah, there is a limit to that. But like, has it been proven that the distances between the house and like the boat are like the same or like different or like? I'm sorry. Do you understand what I'm trying to?
I'm trying to
explain?
get, so basically a mountain, you're able to see it further than something that's shorter because it's obviously taller. So
Yeah,
it takes
yeah.
longer for that mountain to
Yeah.
disappear in your field of view because it has a taller angle of view. So because light enters an eye and an angle. So when something just simply moves away from you, it starts to lower in our horizon because of perspective, again, of the angle of light entering our eye. So something that's way taller than a house, for example, you're going to be able to observe it longer.
But, what
But
I'm
eventually
trying-
even the mountain disappears.
what I'm trying to
Yeah.
like say, I'm not saying this in like the right exact way that I'm
Yeah.
thinking this,
Yeah.
but like you can see like what is the distance where something disappears from your field of view?
Okay.
Like a boat. What
Yes,
is the distance?
6. It's about 6 miles if you're about 5.5 feet to 6 feet, depending on how tall you are.
Okay.
It's about 6 to 9 miles.
Okay.
Yeah.
So,
Sorry.
like, the 6 miles thing, right?
Yeah.
Like, assuming that it's on, like, the flat plains, right?
Yeah.
And
Level
it's, like,
plane.
the field of view, right?
Yeah.
Like, there are things that are smaller than the boat that, like, you can see, like, from, like, farther away from 6 miles. Like, what about, like, a light? Like,
Sure.
say you're 6 miles away from a light and, like, in the darkness, and then they turn on that light. How come you can see that light, but you can't see the, like, but you can't see the boat?
I mean, again, I see what you're saying, but there is a limit to how far you'll see that light as well. So maybe you will be able to see the light because obviously there's refraction on the atmosphere, so it kind of bends the light a bit. So, no, it's just refraction. White light bends. Yeah, it has nothing to do with the ground we're standing on.
So why is the moon a sphere?
Yes. So here's the thing. So if I show you this side of this container, right? It's a circle, right?
Sure.
Right. Does that mean this container is a sphere?
No.
No, exactly, right? So we only see one face of the Earth, of the moon. So how do you know it's a sphere?
I mean, we've seen both faces of the moon, haven't we?
That's.
Or we've seen, like, I've only gone around the moon.
I mean, here on Earth, we only see one face of the moon.
Yeah.
Yeah. So they tell us that they've been to the moon, right, and landed on the moon, obviously, but that's obviously a joke in my opinion. It's just, it was all made in recorded in a Hollywood
Studio.
basement or studio,
Yeah.
exactly, because it's fake, 100%.
Yeah.
So they want us to believe that the moon is a sphere, but in reality, it's not. And even if it was a sphere, I would say it's illogical to assume that the Earth is a sphere just because we see a sphere above us.
Wait, but I have like a telescope in
How
my
would
house.
that be illogical?
Illogical because that's like saying, like, if I go to a room, right, and I see a sphere attached to the ceiling, right, if I observe the ceiling and see a sphere, does that mean the floor is also a sphere? Exactly.
No.
So the moon and the sun are just part of the
Okay.
creation of here
I
on
have a
Earth.
question. So if we're on like the ISS,
Yes.
and we're traveling like around the Earth, we
Yes.
could see like the curvature, and we can't see like beyond like the horizon. But, like once we go further around the Earth, we can like see what's there, and it's all
Ah,
it's all
thinking. Well, here's the thing. The only place you're ever going to see curvature of the Earth, are you guys familiar with the wide angle lens from GoPros? So when somebody goes in high altitude, like skydiving, for example, and they have a GoPro lens or a GoPro camera, the GoPro is always going to curve horizontal lines because that's what a wide angle does. If we use a standard camera, the horizon is always going to be horizontal regardless of altitude. So there's never curvature to the Earth. So never.
Wait, but what?
So this is what the horizon looks like over 20 miles in the sky with a standard camera. The horizon is always horizontal, and I think that's where the word horizon comes from because it is horizontal.
Wait, but what about like I've been on like planes before where you can like clearly see with my eyes like the curvature, and also like
Yeah, then why don't planes go in a straight line?
They do fly in a straight line. So the shortest distance between 2 points is a straight line, and planes do fly in a straight line to save fuel. So
they fly curve lines.
So the projection that they show you in the screen is just a projection. It's not actually doing a
What
curve.
is the objective of
because
doing that?
you're
What is
looking
the
at a
benefit?
flat
of it?
screen.
Well, the
Fly
people,
around.
it basically to stump our critical thinking skills so that we just obey authority over our own
He's got a
common
question.
sense. So
Excuse
it's
I
like
have to get.
people that control government, 100%, yes.
Excuse me, I have to get going. So
Yes,
I just want to ask
one more question, yeah.
Wait, if the Earth is a level, then
Yes.
does that mean that there are ends to the Earth?
Yes.
So like,
Yes.
it's just like, what happens there?
Yeah, so I don't know if you guys knew, have heard of the Antarctic Treaty. So the Antarctic Treaty basically prevents anyone from independently exploring the south of the Earth because in my opinion, the south is the outer circumference of the Earth and you will find a wall or a container of the Earth.
Okay.
Yeah, so nobody's...
fly off.
So then how
You
do
won't fly off because the Earth is a contained system. So because we have air pressure, that's how we're able to breathe.
Is this right wing, like anti-intellectual propaganda?
No,
or
it's-
are you absolutely crazy? Which one is this?
No, this just has to do with physics, natural
no,
physics.
pseudophysics. Vámonos. This guy. Don't waste your time with this
Okay.
ridiculousness.
We can talk to him. It's
Engage with real
Wait,
intellectuals.
but gravity just being a theory doesn't make it like objectively wrong though. It
Okay.
could just be like a theory. Like there's many theories that have been proved right.
Doesn't-
But the upwards push of the Earth is not a theory.
Don't
It's
all
called the
things-
normal force. You can look
But
it
we,
up.
don't, we not knowing doesn't make it wrong.
But theories, but theories don't technically mean that it's not true. Theory just means that like
We haven't proved it.
no, you can prove a theory and still call it a theory.
Well, it
It's
wouldn't
not-
be a theory. That would
No,
be...
but it can be called a theory.
Yeah. Well, here's another way we know that there is no downwards pull or downwards force. You guys all have a smartphone, obviously, right?
Yeah.
So every smartphone has a built-in accelerometer inside of it. That's how you're able to turn it from landscape and portrait, and it switches because it detects the force of the Earth. So an accelerometer is a force detection device. So if you download an accelerometer app to read the G-force of the Earth, and you have your phone at rest, it detects the force of the Earth, right? That's because we're being pushed up, but you guys believe it's being pulled down. Here's the thing, when you have it at rest and you accelerate it in any direction, it detects that acceleration, the accelerometer, up, down, left, or right? Because there's a change from being at rest.
Yeah.
When you put that phone into free fall, guess what happens? It detects zero acceleration. That's because it's not being pulled down by a force, it's just being left behind due to inertia.
So you're saying
So the force of the Earth is only felt when you're physically connected to the Earth.
Or
So
maybe
is the plane
it
of the
includes
Earth like
gravity
pushing
inside
up?
of it that like includes gravity?
How about for like other planets where like gravity's not as strong as Earth? Like,
Hold
how
on.
does that work?
Well, we're talking about imaginary places now.
Oh, right.
So nobody's been to the outer space to be able to confirm that these planets are real. Like, and all that CGI, they're cartoons.
Okay,
So what
Yeah.
about telescopes then?
What about them?
Like you, I have a telescope at home. I can like you can like kind of like see the craters, and like different days you see different craters and stuff. Like it's not like that's just a projection, like a CGI.
Yeah, it's not 100%.
So-
It's a creation of whoever created this place. I don't know what the moon is. I could tell you that.
But then
honestly.
if I see it having different craters every single day, wouldn't that mean it's rotating, and therefore it would be a sphere instead of something that's just
No,
facing
yeah,
us?
I think the moon does. It obviously does rotate like this.
So if it's a sphere,
No,
because
it
if
doesn't
it's-
rotate like this. It rotates like this. It's like me rotating this like this.
No, but then
So you
I'd
only
see
see the
different.
front.
Then I'd see the craters instead of here. It'd be here, instead of it just going to the other side.
Okay. Well, even if that were true, I honestly don't know what that would be, and that wouldn't prove that the Earth that we walk on is curving and it turns into a ball.
So what like proves that it's all every single like thing is just facing us then, like every single, because why wouldn't we be seeing it like this? Because that would also have to mean they're facing us like that, right?
Right, I don't know. So again, the sun and the moon are just lights, which I don't know. Nobody knows what light is. I don't know if you knew that. Even the light that we use to see right now, nobody knows what it actually is, because it's not matter. Light is not matter. So these luminaries, the sun, the moon, and the stars, they say it's waves. They try to describe what it is.
Light, they can
Like
turn into
photons,
matter.
they say it's photons, not protons, and you know.
Yeah, I mean,
But again, those are just theoretical concepts of what light is. But nobody knows exactly
we're
what it
saying
is.
theoretical like we don't know.
Exactly.
But we do.
Again, you could believe that's fine, but the reality is
what about-
we don't know what it is, and it has nothing to do with the
What
shape
about
of the
light
Earth.
hitting
What
water and
light
then you
is.
see it get distorted? You can see with your own eyes.
Yeah, that's because there's like little waves in the
Okay, what about
in
like
the
a
water.
prism, where it breaks up the light into different colors?
What about it?
Oh, prism.
breaks,
Like,
it breaks
that-
down.
that-
like the different waves.
Okay, does that prove a globe somehow, or?
That
We're
proves
not
light.
talking about that.
Okay, well that's what I don't know what that is. You know, all I know the physics that debunks the globe.
I'm saying that's what proves that it's a wave of light.
Okay, sure. You could believe it's a wave, and again, I won't accept it and I won't dismiss it. Sure, I'll be in the middle. I don't know what it is,
So, like-
but again, that doesn't prove a globe anyway.
What would like prove to you that the Earth is a sphere?
That it is a sphere.
Yeah, like
Well,
if it was right, of course.
So first, there will have to be a pulling force of gravity that can be measured, detected, and recreated. Because gravity, as a pulling force,
Is it a 9.81?
yeah.
meters
So
per
they
second?
measure the distance in which a free falling object takes to meet the Earth. But they're not measuring whether the object hit the Earth or the Earth hit the object. We're just measuring the distance it took and the time it took for them to come together.
So you're saying would the object have to be like floating in the air somehow?
It's not necessarily floating, but it's
Like
losing momentum. So everything is being pushed up at the same speed right now because we're connected. So as soon as something's disconnected from the Earth in free fall, it starts to slow down. So the Earth just catches up to it. So it doesn't necessarily just stay floating, but there is no
How do you
force.
know that?
Because accelerometers show me that, physics shows me that there is no downwards pull and the force is up.
So you're
everybody-
saying that the Earth is like a plane, like this, and it's
Just pushing up. Yes.
Why do you think like people
Yes.
alarm?
That's what gravity is. It's the upwards push of the Earth.
They wanna
That's
get
the-
rid
That's
of-
the true gravity.
So why do you think everyone is just lying to
Yeah.
us?
Why do
Oh,
how come,
so
like,
again,
no
I
one
think
knows
I've
you
said
said
it.
the critical thinking.
Yeah, it's to stump our critical thinking skills so that we just obey authority over our own common sense so that we're more easily controllable. So it comes back to control. It's about controlling
Do you
humanity.
think the government's gonna try to shut you like?
Well, they're just censoring my channel completely. My channel hasn't grown in over
Are you-
2 years,
you're a
so
YouTuber?
it's just frozen. Yeah, I'm actually on YouTube.
Oh, okay.
Yeah,
A
it's
lot of
right.
people tried for like over 10 years.
Yeah, actually, it's just believe it or not, I'm like the only one that's out speaking to people about this. There's not one other person that's doing this, which is crazy because I came
Crazy.
across this 10 years. Who?
Fuzi, he believes in flat Earth.
Yeah, but he's, I hate to say it, but he's not the smartest. He's not the smartest guy. He's actually kind of dumb in my opinion. But it's just my opinion, obviously.
We
gotta get back.
So no, any questions before you guys leave? I mean,
So Earth is like
Wait,
a
but if
geoid?
the accelerometer...
a what?
A geoid is like a, I think, perfect sphere? Or,
No, it's just a level plane. Yeah, it's not a sphere at all.
or it's like a spheroid, like kind of it. Like, is
No,
it-
you're talking about an oblate spheroid?
Yeah,
it's not an oblate spheroid. Yeah.
Are we gonna be on a
So
video?
here, yeah, here, maybe you guys my channel.
Wait,
Here, I'll give it to you.
Wait, if you're...
Thank you for changing our perspective.
There you go.
If your wait, if your argument is that like we don't know, that doesn't like
Thanks.
mean it's flat though. Like, why would it prove that it's flat? And why would, if it was flat, it would be pushing upwards?
Well, that's what physics shows, because buoyancy is an upwards push of the Earth. And in order to have an upwards push of the Earth literally has to be moving up. And if the Earth was moving up, it couldn't be a ball.
But the Earth isn't buoyant though.
No, I'm not saying the Earth is buoyant. I'm saying it creates buoyancy. Because it pushes up the air, and the
So, like,
air is
on
able to
this
push up
map,
lighter
we
objects.
have North America and South America.
Yes.
Right? Yeah. So like, where the hell is Europe?
It's on the other side. And on a block, it's on the other side. But in
So how do
reality...
we fly to Europe?
So here's how we do it real quick. Let me just show you.
Wait, how would we fly
gotta
from
go,
America?
boys.
How would we fly from California to Japan and just skip over all of
So
that?
I don't push any maps, so I don't think this is what the Earth looks like. But if it was a ball just opened up, the North Pole would just be the center.
32 views on this one.
Oh Jesus, he's flying.
Yeah, and then
everyone.
and all the continents are just around the spread around the north. So when airplanes fly from LA, for example, to any other place, they just go in straight lines like this, like that.
But what if it was going to Japan?
Japan
Why-
will be over here. Yeah,
Earth is just
like
plain,
that,
not
straight.
a sphere.
But then
And he's live right
then
now.
why is it?
Is this
why would it be
Pangea or what is this?
No, this is the Earth.
This is the Earth?
Yeah, this is the Earth. I'm not saying this is what the Earth
So
looks
do you
like,
believe in
Oh, yeah.
Garth?
but if we just opened up a globe, make
Yeah, I
it
bet if
level,
you stretch it out, that's what it
yeah,
looks like.
this is what it would look like.
Wait, what about like a Gartha? Do you believe in that? Like, if like, is there like a civil?
Yeah,
I think the Earth-
do you think Nazis live right here?
No,
Oh, okay,
no.
sorry.
The Earth is a contained system. Nobody can go outside of the
Oh, I
Earth.
always heard like people think this is an ice wall, then everything actually
Yeah, I don't
is just,
believe
like,
in that.
crazy
Yeah,
shit.
I don't believe in that either.
Oh, you
Wait,
know?
so you can't
Isn't
fly
like a Gartha
here?
past this?
How do you think the sun works? Like, because isn't half of this supposed to be data time?
Yeah, so the sun is very tiny in comparison to the Earth. And
Oh,
very
really?
close by. Yeah.
what
So
Oh,
you're
I
pointing
always
at
heard it was really far.
No, that's what you were
what
told.
about-
That's what you were told.
What about
But then
mysteries?
why is it hotter around this equator line then, and not hotter like?
I would
right
again.
there?
I don't know 100%, but it
You
would
just
have to
have,
do
like,
the
extra
sun.
views?
The sun moves in the center.
Oh,
of
you think
it.
it just moves right here?
Yeah,
then
it's very
what- oh,
tiny.
yeah, I got a
like,
line.
it's smaller than this line.
But
But
isn't
then,
that,
wouldn't it be too close to keep this all ice? Like, wouldn't this shit all melt?
No, because even the north doesn't melt.
Wait, you're saying
Yeah,
this-
but-
Completely.
you're saying the
I
sun is
guess,
tiny?
yeah, that's what you're saying.
Yeah.
Wait, I'm kind of getting, I'm kind of getting on board with it now.
Okay. The map's irrelevant. Now let's go to physics.
No,
So-
physics.
So you guys believe the Earth is a ball, right? So a ball has to have curvature, right?
right?
Yeah,
right.
yeah, yeah.
Do you guys know the radius of the Earth to know how much curvature there should be?
I'm sure it's a fucking shitload.
Okay, I'll show you. So here's the radius of the Earth. They tell us 3,959 miles, which if we
That's
multiply
not as
that,
much as I thought, but yeah.
yeah, if we
sounds
multiply
about
that times 2, we get the diameter, and if we multiply
about-
the diameter times pi, we get the circumference. So the circumference of the Earth is 24,101 miles based on the radius they tell
Wait,
us.
okay, wait. So what's the? All right. keep
Sorry.
going, keep
So
going, sorry.
using a simple calculation like the Pythagorean theorem, a squared
Okay,
plus
okay.
b squared equals c squared, we can calculate for how much curvature there should be based on the radius they're telling us. So it turns out there should be 8 inches per mile squared. What that means, in the first mile, there should be 8-inch drop, second mile, 32 inches, and by the third mile, there should be 6 feet of measurable curvature. And in 10 miles, there should be 66 feet.
That doesn't make sense.
So that's based on the radius they tell us. So you can look it up. You can literally
No, yeah,
Google
I know.
it.
I don't
So,
understand it.
so here's the thing. If we went out to actually measure for the curvature of the Earth, if we went out to a giant lake, for example, that was filled with water that was 3 miles across, and we build a level structure above the body of water, the water on the lake, when it's at rest, is going to be parallel to anything horizontal above it, because that's the physics of water. The surface always collapses to form a level, and they're trying to tell us that every lake on Earth is bending.
I saw that. I saw that.
I don't think they're saying that every lake is bending downwards. I think they're saying
based on the
I
relative
think,
starting point.
Oh, let me finish. I think
sure.
they're saying every ground mass fills and the lake like sits inside of like little cups or bowls of ground. You know?
Yeah, 100%.
So, like, it doesn't have enough
What
room
about
to
the
go down.
surface? What's the shape of the surface of a lake?
It would be flat on top because
Exactly.
because it's not sitting on the rounded part. It's sitting in the bowl that
Yeah.
that fills the water.
Now, if we extend that lake over miles and miles,
Well,
how-
you've
the
seen
surface-
craters. You've seen craters on the moon, right?
Sure.
A lake could theoretically sit in a crater
crater on the moon. Do you believe the moon is round, or do you
No,
believe
but
it's flat?
there's lakes that are over 100 miles long. That surface of that lake should bend because of you believe in gravity pulling it to a center. So the surface of the lake in 100 miles should be bending over a mile.
And they've put like rulers across that whole 100 miles, and it's totally flat.
Have you heard of Euclidean geometry?
Is this why half
So
our
Euclidean
taxes
geometry is the geometry used to build everything here on Earth, which it comes to railroads and bridges.
Oh, shit.
So all of those calculations don't take account of Earth's curvature. They all assume the Earth is a level, and all plumbs are parallel to each other.
Someone put in chat. Imagine
So
those
physically,
We're trying to learn here.
Yeah, physics shows that the Earth is a level plane, and it's physically impossible for it to be a ball.
Well,
But how does gravity work then?
Gravity is an upwards push of the Earth.
Wait, I have a genuine.
So the Earth is not pulling you down to the Earth; it's the Earth pushing up against you right now. So if the Earth was a ball, it couldn't push up.
So I'm floating, and the Earth is pushing.
Yeah, you're not floating because you have inertia, so you resist that upwards push because your body wants to remain at it in its position in
So
space.
where's the Earth going? What's pushing the Earth back down and
So-
stopping it from going up?
Yeah, so the mechanism of the Earth's motion, it's unknown because nobody's been outside of the Earth.
Wait,
So the Earth is a creation.
I always
100%.
heard we were just being pulled in by the sun, and then our Earth had enough to pull us onto our own little Earth.
Wait, I have a genuine question.
Sure.
Wait, can you pull out that?
I'm an idiot.
Okay, I don't like to talk about this map because it's irrelevant. I don't believe this map either. I just show it as
I
reference.
still have a question. One
It's
second.
all-
Wait.
Oh, yeah.
So like, you know how like, hold on.
Missed our game for this.
we have the
Well, one more question, then we
It's
can
only
go.
first
Okay?
quarter, we're chilling,
You know how like days are longer.
Yes.
Like there's more sunlight in the north and the south, or like
Yes.
whatever,
Yes.
Antarctic and Arctic.
I'll
whatever.
explain that
So
real-
is there like one sun here and like one sun around here? Like how does that work?
So I can dismiss that because there could be multiple suns that they're not telling
But
us
there's
about.
one-
I don't
But here's the
see
thing. But here, I don't. Even if we don't go with that, the sun when it circles above the Earth, it goes in, makes smaller circles, and out, makes wider circles. That's why the angle of the sun changes.
Okay,
throughout
so
the
why
year.
is it like super daylight up here and then
So-
it goes nighttime and then it goes daylight?
No. So what happens in the north when you get like 3 days consecutively with no night? That means the sun is making small circles in the center. So the sun's obviously always visible. So when it starts to make a wider circle, then it
But
starts to
wait,
disappear.
so what
and that's how you
continent? What
get
continent would
How
this
does
be?
the sun?
What continent would that be?
That's
Australia.
Australia.
Yeah.
Well, Australia doesn't get 3 days of full night when this is getting 3 days of full sun. How does that make sense?
Well, because it's in the outer, it's below the equator, so the
Well,
sunlight
yeah. So
wouldn't
while the
reach.
sun is shining all this, it reaches there.
No.
No.
So Australia
this place
does
gets
get
no
3 days
sun.
of
This
night?
place gets
Oh,
no sun.
so again, I don't. That's why I don't buy into any map because I don't know the full layout and how the continents lay out. I think this is all a lie as well. I think we have more continents. I think the continents look
We should just get a
differently.
drone up there, man.
Wait,
I mean,
what
but that's
about-
irrelevant to prove the shape of the Earth, though.
How
Wait,
is
but
that
what about
prove the
Mr.
shape there
Beast?
that we could see it? Like that kind of proves
Well,
it.
we can only go so high.
Wait, so
That's
do you
the
think
thing.
all those
Don't
satellites?
they have like space balloons really high too?
Helium balloons? Yeah, they only go up to 20
Wait, so do you think all those
25
satellites in?
miles.
Do you think?
That's the limit of how high you
Wait,
can go.
so do you think all
Do
those
you believe in
satellites
satellite
in
imagery?
the
You don't
all
believe
those
in
satellites
satellite
in space are fake?
Yes.
What about?
Really?
Wait, what
So you
about?
think SpaceX is fake and all that?
Oh yeah, 100%.
What do you think about Mr. Beast going to the Antarctica? Though? If you said it's like not allowed.
Mr. Beast.
Well,
Yeah.
you could go, but you have to pay a lot of money, and you're always gonna have
Has to be with an
somebody.
expedition, bro. It has to be with a trip.
Yeah.
What do you think about? What do you think about?
He's gonna be a
What do
guy.
you think about the recent expedition where they circled around the moon and came back?
Yeah.
Do you think that was all fake?
Yeah, 100%.
Why?
What about the Apollo?
Even when even
Wait,
they
what about
landed in the
Apollo
shuttle,
missions?
What about Katy Perry?
Yeah.
the filming of them landing in the shuttle.
Yes.
Didn't
yes.
they just
Do
relay on the
you,
moon?
do you
or some
believe
shit?
no one
Yeah,
left
yeah,
Earth?
it's all fake.
Nobody has left
Oh,
Earth.
it's all
Nobody-
fake.
So how do you think like
Nobody can
Our
leave
game-
Earth
our game
because it's
will
a
be back
contained
at 12.
system.
That's
Earth
why
is a
Earth-
contained
Do
system.
you believe the moon is round?
I don't have to believe it. It is round.
Okay,
But
so
just
why
think-
would the moon be round but the Earth be flat?
Here's the thing. If I show you just this side of this container, would you say is round?
No.
No,
This is not round?
looks like a cylinder.
No, it's a 2D.
No. Just if you just see
Oh,
this.
well, it's a circle, but it's flat. So
Yeah.
It's a 2D
Does that
shape.
mean this is a
Cylinder.
sphere?
You can see
Looks
multiple
like a cylinder.
sides.
No, exactly. It's not a sphere. Just because we only see one side of the moon. I don't know if you knew that. So why do you assume that it's a sphere
So
then?
then why is every
see
single thing
multiple sides.
facing
Yeah,
up?
So I would say it's illogical to
I-
jump to the conclusion
Well,
that
the
it's a
mission where
sphere.
they circle around it too.
Well, again, that's just
Wait, I have another
CGI, just bullshit.
This analogy is wrong because you can see a half sphere from the moon. When you look at the moon, it's a half sphere because you can see it's like going
Also,
like this.
what do you, how do
This
you
is just a 2D like.
how do you think moon phase? How do you think moon phase?
I feel like it's
Have you ever
wrong.
heard of a crescent moon?
You just see a
A
circle.
crescent moon.
Sure, crescent moon. Yeah.
What casts the shadow onto the crescent moon?
I don't know.
The sun.
Oh,
You don't know?
Yeah, I was about to say
No, it's
that.
not magical. It's part of whoever created this place. Obviously,
It's because the
made it
sun
do
is
that.
on that side,
Sun? The Big
and it
Bang?
has
Yeah.
to.
Wait, do you believe in the Big
and
Bang?
it,
No, I used to. I was
Wait, but
atheist
if-
before
if
all
it's
this.
proven,
so
how can
this
you-
proved to me that
When
you're
when
not
it,
atheist
this is a
now?
how
creation.
long ago did you start believing in flat Earth?
Well, it's not flat. It's not flat. It's level.
It's a
level
Earth.
plane
Yeah,
field.
because flat earthers claim the Earth is motionless. They deny the upwards push of the
How do you?
Earth. But yeah,
Oh, so you're
so
not atheist anymore?
no, no.
You believe in a
I-
God?
Well, I believe in a God. I don't claim to know what that God is.
Oh, so you're not religious?
All religions are bullshit. So anybody trying to tell you what this place is and how it's created is bullshit.
regular moon
Oh,
phase, so I know you
you only believe in
Wait,
one
but what
God,
about
that's
if a
I
religion?
believe that this is a I accept that this is a creation. I don't even have to believe that because the first law of thermodynamics shows that something can come from nothing. You know, so something can only transform from one thing to another. So again, them claiming that God created the Earth from nothing or the Big Bang
You
created
don't
the
believe in the Big Bang?
Sir, do you think astronauts are real?
Do you believe in Jesus?
Well, they're real, but they're
My
lying.
friend,
Wait, so you think
so
all
my
that-
uncle
go to
is
the
literally
moon?
like an astronaut.
100%. All
You think-
astronauts are lying.
You think the Holy Bible and all that books of God is fake?
Yeah, religion was there before government to control people. So all religions are there to control. Government is a religion though, with the heliocentric model, Big Bang, all that's just
And
a
you think
religion.
none of this would have got leaked by the government?
Well, they're suppressing it. Yeah, 100%. My channel will never grow or never get recommended because they're suppressing this
Or
information.
wait, but is that just because people don't believe it, or is that because there were?
Because it's so easy that a child can understand, so they don't want it to spread to new people.
Well, it's because it's easy to manipulate a child.
What
That's why.
happens during
Well,
the
if a
eclipse?
child has a mental capacity, like a 10-year-old, to understand the physics that debunks the globe, obviously they want to keep that away from the masses because then people are going to get it.
Well, it's because it's oversimplified, is what you're saying. You're oversimplifying.
Well,
all
because
the-
it is simple. Reality is simple to understand. It's
Not
basic
really.
physics. It is basic.
Are we
no,
going to
they,
be on a YouTube video later?
Sure, yeah.
Are you
guys
going to
can
edit
check
us
it out.
into it?
Yeah, I don't edit the conversations. I just put them all as a whole.
Okay, cool.
So yeah, I don't do none of that editing.
What
shit,
happens during
talking
an
shit.
eclipse?
Yeah,
I'm sorry?
What happens during an eclipse?
Well, obviously one of the bodies of, it's in front of the other body and apparently blocks out the sun, like the moon, for example.
So
I don't know
is
what
this like
it
a
is. though.
theory of
A
yours?
lunar eclipse.
Sorry?
This is a theory then, yeah?
No.
Because we're
It's
asking a
fact.
bunch of questions about what happens all.
Yeah, when it comes to the sky, nobody knows what these lights are. Not even the globe earthers or globe proponents. They just make up theories to reinforce their model. So nobody, and it's irrelevant to the shape
So
of the
isn't
Earth
this
regardless.
your theory
No,
too?
I'm
Because,
talking
like, how
about.
can you prove that then?
I'm talking about well, I can't prove this map, but I can prove that the
or
Earth
like-
doesn't curve
yeah.
because the physics of water, for example, the oceans are perfectly level. That's where the term sea level comes from because the oceans are horizontal.
The gravity
So
is pulled.
again, a theory of gravity being a pull doesn't exist.
So theory.
It only there is only
And
there
is it
to
a
explain
theory
the
of
model.
push flat Earth or level Earth?
No, because again, water
Water
being
is
level is not a
only
theory.
level
Every pool on
relative
Earth,
to
every
you.
lake on Earth, the surface always collapses to form a level because water can support itself. Because water doesn't have a shape.
Wait, okay.
The
So
surface
Wait,
always
what's
makes
the
shape.
timestamp of like when these boys showed up? Do you know? Like
I-
how long is this stream gonna be?
I've been on for an hour, so you guys can rewind like 30 minutes. So 30 minutes in the video. Probably.
okay, wait.
Are you gonna
But
be here after like an hour?
I'll be here probably a little over an hour, and that's it.
if you're saying it's all true, you said like I don't know a bunch. Like you said I don't know why why every single thing is facing facing
Yeah,
us
no
and
worries,
isn't
man.
like
Take care.
sideways. You said like I don't know that like
Nobody
what
knows.
light
That's
is.
the fact.
No, but
right now, but thank you.
All right, man. No worries, guys. Take care. All right, take care. Whew. 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 Oh, what's up, Del? Selenalian. Ambience Electronica. God damn. It's my water. Ooh, here it is. Oh, man. I think that went really well. Obviously there was some pushback, but nonetheless, I think we went well. Again, you can't have a globe Earth that's pushing up, which is what physics shows that gravity actually is. You know, gravity, it's an upwards push of the Earth, not a downwards pull. You know, so you can't have a globe that's pushing up in every direction. You know, up is not relative in reality. You know, up is singular. You know, everybody's up is the same. How do we know that as well? All plumb lines, which is a vertical line, you know, are parallel to each other, which on a globe, a parallel line here is perpendicular to a parallel line here, you know. So those two lines are not, they're not parallel, I mean. So again, a plumb line here is perpendicular to a plumb line here, which are obviously not parallel, you know. But in reality, all plumb lines, regardless of distance, are parallel, because all plumb lines are perpendicular to the levelness of the Earth. You know, that's the only way to have, you know, plumb lines being parallel to each other. They're extended over a level plane, which is literally how they build everything here in reality, in this reality. You know, the engineers, you know, they don't take account of the Earth's curvature, and they all assume that all plumb lines are parallel to each other. That's how they're able to get, you know, pretty precise measurements when building bridges, when setting railroads, you know, when building houses, you know, everything. Obviously, houses are a much smaller scale, which I get. There's going to be an excuse that, oh, on a very small scale, like, yeah, you know, plumb lines are parallel to each other, but when you extend it further, then they're not. But again, bridges can be miles and miles long. Railroads extend for hundreds and hundreds of miles long, and again, there's no curvature that anyone takes account for when building long distances. So that's just the reality, you know, and again, people can accept it or just continue to be willfully ignorant, you know. That's a personal problem at that point, you know. Reality is what it is, and it's not going to change, you know, whether people like it or not. You know, again, the downwards pull of gravity that everybody believes, even flat earthers believe in some kind of magical force that can accelerate objects in free fall. That force has never been measured or detected for a reason, because it doesn't exist. That's the reality, you know. So again, this doesn't fall due to a force. This is not being forced down in free fall. Yes.
Alright, we're back.
Yeah.
I have one. The game before us is at half, so we have time.
Okay, fair enough.
So if like
No, let him.
Wait, let Colt ask his question.
I was gonna
Ask your question.
wanted to say
about the planes.
I have a really good.
No, about the stars and shit. Go.
Yeah, you can see different stars at different angles.
Yes.
So if the Earth is a level plane or whatever, why can't we see like Mount Everest, right? The tallest like structures.
Well,
Yeah.
we have rendered this.
Yeah, it's due to perspective. So you have a limit to how far you can see. So everything shrinks down to a point the further it gets from you until it reaches a vanishing point, which is the horizon.
What about
It's like
telescope?
binoculars.
Then why can we see stars that are hundreds of thousands of miles away?
So that's what I was gonna say. You guys believe that these stars are light years and light years away, but in reality, they're actually within Earth's atmosphere, like within the Earth containment. They're really close, actually.
So then why when you
And
wait?
here's another
What?
thing. So the stars are just a reflection of light, which I don't know. Nobody knows what they actually are, but they're really close by. And that's how we're able to see them.
Wait,
Also,
they're so close.
when you're on a plane, you're more than 6 miles above.
Sure.
But you're 40,000 feet in the air.
Yes.
But you can still like look down and see the ocean. That's
Sure.
yeah.
Yeah, because
So you can
ocean's
see more
huge.
than 6 miles.
You can see houses from.
Yeah, but that's because there's nothing obstructing your angle of view when you look down. When you're looking across the
What if
Earth,
there's a flat?
the Earth.
I have a question.
Look at
Mount
Mount
Everest is over there. There's nothing
Wait,
that
wait.
can stop me.
Here,
from
let me
seeing
show
it.
you guys real
Why
quick.
when you go like south or something?
So here's the thing. Let me show you guys how perspective works. So, for example,
Is that the
these
backwards?
railroad tracks, we know are parallel, right? They're parallel.
Yeah.
But it looks like they converge when you look at parallel lines at a distance. It looks like they converge, right? But we know they're not. But that's because we have spherical light. So the angle of light entering our eyes decreases the further something gets away. So that's why everything shrinks to a point, right? When you're looking at long distances over water, for example, here, let me show you this graph now. So this arc represents our eye because, again, our eyes are spheres. So when something is above you or below you, but it just moves away in the same altitude, the angle of light changes how it enters our eye. So eventually that's why things shrink at a distance, right? So when something goes over the horizon and you can't see it anymore, it's because the ground or the water that's in front of that object, it's obstructing the view now. So when you're looking straight down from above, there's nothing obstructing.
Wait, so I have
You
a
said
question.
over the horizon, which means
you-
that there is.
That's
like,
the limit of perspective, though.
Wait, but if
Someone
you
in
zoom,
Top one at a time.
if you zoom in on a telescope or something, it does the same exact thing. Wait,
Sure.
It does the same exact thing, but it's over there, and now there's a new parallel. where
So
it's
telescopes
converging.
increase your perspective.
Yeah,
But
so,
even telescopes have a limit as well.
So is space?
Yeah, but then
So
you
what
can
if you
see
use a
it.
square telescope?
Here's another thing. Even if we had infinite vision, which we don't, and it's impossible, but even if we did have infinite vision, we wouldn't be able to see Mount Everest because the atmosphere gets in the way. So you're going to be looking through atmosphere, miles of atmosphere, that would prove that you can't see forever
That
because
would
of
prove
fog.
that but what if there's no fog?
Well, that's the thing. You will have to take the atmosphere out of the Earth, which is physically impossible.
What if
You would die. We need it to breathe.
Do you think like space is
I don't-
fake?
Space, what they show us, outer space is like planets and the emptiness of a void. That is fake, but there is definitely something outside of the Earth. I don't know what
do
that
you
is.
think?
Do you think it's like it never? You think it's never ending or like it's
I
a
don't
shape?
know. So the Earth exists and it's moving up, pushing up. So it's moving through something. So outside of whatever's outside of the Earth created it, And the Earth is definitely moving through an area. I wouldn't call it like
So
outer space.
when they say like the Earth is rotating at like 1,000 miles an hour, do you believe in that or not?
No.
You think it's just still?
No, the Earth is moving up, pushing up.
Do you believe the stars are really close to the atmosphere?
Okay, wait.
They're within the containment of the Earth, in my opinion. Yes.
Wouldn't it be like, because stars are bigger than planets, wouldn't they be like burning us?
Well, that's just you're told.
As we're still
You're
in
just
high school
believing.
chat,
You're still just believing what you're told, and that doesn't prove the ground is bending or.
Wait, do you think the Earth has two sides?
I don't know what's underneath it. Nobody's been outside of the Earth to see it as a whole. But the surface that all life inhabits is level.
Wait, so wait.
100%.
If you move south, why would like if you move south and like up, why would stars look higher? Wouldn't that prove that
Due to
you're not on a level
perspective.
plane?
So when you're observing a star, because they're really close, they're not far like they're telling us. They're saying that the angle changes because you're going down a curve, right? So you see the different angle, right? The reality is you see the different angle because it's just dropping due to perspective. So when you move away from the North Star, for example, it starts to drop in your field of view further until you can't see it anymore. That's because you're not going down a curve. That's because it's just the perspective.
But if you go south, it would go up instead of going down.
No, the north will go down if you go south because the North Pole star is at the north. So the closer you get to it, the higher it gets in your field of view.
How would a compass work?
Compass works because of the magnetic field of the Earth, which is at the center point of the Earth. So the north is the center on the level.
So where's the north?
Where's like?
So the south, there is no south pole because compasses don't point south. So the south is not a pole.
So where's the north?
The north is the center of the Earth. So like I was showing in this map, which again I don't.
So why is it magnetized towards the center of the Earth?
I don't know.
Is there like a metal pole there or something?
I don't know. Flat earthers, which again I'm not a flat earther. Flat earthers claim that it's some magnetic mountain, but I don't even think that's true either. I think the north will show what is creating this magnetic field, and it will show that this is a creation without shadow of a doubt, because the north is actually restricted to explore as well. So nobody can actually independently explore the north to find out.
Okay, wait, but
that is a good question though. I thought about that. What is creating this magnetic field? That is a good question.
Wait, but
or spinning rotation.
If helium, if like what's it called? If it was proved that like the Earth was a sphere and wasn't flat, before that, why would they not do that before? If they wanted everybody to have no critical thinking skills or whatever, like you said, why would they not have it as a sphere?
Well, they had to implement it sometime, right? It didn't exist in the beginning of time, so they implemented it when they implemented
was the sphere in the beginning of time?
No, 100% no. So people understood that the Earth was a level, actually. You know, all religions actually.
So then why are asteroids what circles and spheres?
Oh, you're talking about asteroids that supposedly come from outer
Say
space?
what you said.
When did people first believe that the Earth is?
I know you said in 5 minutes.
Why would they?
What would they even believe that?
If you're right about this,
They didn't believe it actually. So the reason why people believe it nowadays is because they showed the fake moon landings in 1967, and that's where majority of people started to believe it. Before that, a lot of people didn't believe it. More than half the population didn't
No,
believe it.
ancient Greece knew
Yeah.
that the Earth was flat, or knew that the Earth was round.
Sphere.
Like Socrates. Like,
How did they know that?
They calculated it.
Wow.
One person walked like more than 5,000 miles just to prove that the Earth was flat.
Oh wait, isn't there one guy that's walking around the entire world?
Are you talking about the sticks and shadows experiment? Where some guy put a stick with a shadow with the sun right above it, and then 500 miles away he put another stick, and then that stick had a shadow and the other one didn't. So that can easily happen on the level Earth with a very small local sun. So if you have a spotlight right above a stick, obviously that stick's not gonna have a shadow, right? But if you put a stick over here, that stick is gonna have a shadow because the light's coming in this way now. So again, that doesn't prove a globe or a level.
So how can you prove the size of the sun?
You can't.
So
Nobody knows.
You're saying it's smaller though?
I would say it's way definitely
So
smaller.
why?
It's an assumption, yeah. Yeah.
Wait, so
Again,
why
the
is all
luminaries
this
doesn't prove the shape of the Earth anyways. It's the physics here on Earth.
What happens during a lunar eclipse?
I don't know. I don't know.
Then why would it block it?
I don't know exactly what happens. I mean, obviously something
So you
covers
don't
something
have
else.
these answers for like natural phenomenons that.
But but these natural phenomena have nothing to do whether proving the Earth is a globe.
It
or
does.
not. No, it doesn't.
It does.
Wait,
No,
but
on the shadow of the moon, you can see a curve of the Earth.
Sure.
Yes.
Yeah, I agree.
Yeah, so it proves that the Earth is round.
Okay, so if the Earth was round, we should be able to physically measure that.
Yeah, so why is it
roundness of the
daytime
Earth.
in some places
We can.
and nighttime in other
Water
places?
will defy that claim.
Wait, where's the daytime
Water
in
is
some
level
place?
relative to where you are.
So you're saying it does
down
prove
in-
it.
like-
So
like
if we-
down
okay,
in Australia, it's
so relative to where you are, I get it, right? But if we build relative to a plumb line and just build 90 degrees from the starting plumb line, in other words, build a horizontal, the water should deviate from that level, right? Like this, if it was a bomb, but it doesn't. Water doesn't have the physical ability to bend on the surface. Yeah, gravity is just a word.
If
So
you
what-
are right
It's a
about
theory to top
if
it
you
off.
are right about all this, like why does it matter?
Okay,
What
that's
matters?
just the science.
It's a
Again,
critical
that's the
thinking thing.
Yeah,
Wait,
exactly.
what is
Okay.
It's about common
Wait,
sense.
so what
wait.
research has to come out to prove that like
Yeah, we gotta
Earth
go.
is like a,
Wait, but
a sphere and stuff?
the entire
Sorry?
No, it's fine.
the entire
Thank you.
argument relies on that the government is lying to you. But what if like they weren't lying to you? Would would the Earth still be flat or a sphere?
100%, yeah.
So then why would there be so much research and everything, and it's been like proven and everything, but like everything like you're saying I don't know a lot. Like,
Yeah, I'm saying I don't know a lot to a lot of things that can't be proven. Not even they could prove it. They're just assumptions as well. But they use them to reinforce their model. That's the only thing.
Okay.
Yeah. All right, man, no worries. Thank you. Yeah. Take care. Oof. All right, let me check some of the comments. People watching, see if there's anyone. What's up, Base Truther? Sean, Selenelian, Siennan, Tamashitomo, Del, Nat, JT, Eyes Wide Shut, Renewed Awareness, Tempa, How Dare You, Mr. Cheswick, John, what's up, and everyone else watching, what's up? Thanks for being here. Yeah, the last conversation got, they were getting a little emotional, I guess you could say. I don't know what else to say. A little defensive, obviously, which is normal, obviously, you know, like coming across this information that contradicts a core belief that you believe your entire life. It's gonna pull some strings, you know, at the end of the day. So that's what happened. They kept coming back. They came back like 3 times. They wanted to stay longer, obviously, but they had somewhere to be. But it just shows that you know, the cognitive dissonance, you know, that people have. You know, when something contradicts a core belief that they may have, they're gonna go against it regardless. They're gonna avoid the simple physics that debunks their belief to just defend the belief, because that's, you know, psychologically that's how we were trained. You know, that's how society trained us to just dismiss our common sense, you know, in favor of what an expert said, and in favor of images they show us on TV. You know, all this CGI and all this bullshit, right? So yeah, I mean, that was just a perfect example of that, you know? No different than most of the conversations I have. We already know this. But yeah, at the end of the day, it's about spreading awareness about this subject and, you know, planting seeds at the end of the day. You know, planting seeds, and hopefully people are honest enough with themselves to accept the facts one day and push this forward. You know, because again, at the end of the day, it's not about the shape of the earth, you know? It's more about having common sense, having critical thinking, independent critical thinking skills to be able to discern information for yourself, so that you're not just swayed by consensus or just baseless claims, and that could lead to just being controlled, right? So it's about breaking from that mindset of just believing experts and consensus of people that are claiming things that contradict our everyday experience. You know, and we need to break from that cycle so that we can truly become independent critical thinkers. You know, so that's what it's about at the end of the day. YouTube Live. Yeah. All right. Here, 2 very easy questions, multiple choice.
Okay.
All right. We'll start with the first one. So here I have 3 box trucks. They're completely sealed. They're all on a level surface, and they all have an apple inside hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3 box trucks, which one is at rest?
Which one is at rest? I'm gonna say B.
Yeah, you agree?
Yeah.
Yeah, it is B. How'd you know it was B?
Because it's at rest, so it's like...
It's not moving?
Yeah.
Yeah, pretty simple, right? Which one's accelerating forward?
A.
Would you agree, or? Yeah, you got it. How'd you know it was A?
Because it's accelerating forward, so the thing is, every motion has a equal and opposite reaction.
Well, every force has an equal and opposite reaction. This has to do with an object at rest will remain at rest.
Okay, unless acted on by the force.
So when the truck accelerates forward, the apple's not being forced, so it just stays in its position due to inertia. So it just gets left behind, and the truck moves forward.
And then it has to pull it.
Yeah, and then it has to pull it after. Perfect. So the second one, pretty.
Are any of these trick questions?
No, they're all pretty simple. A 5th grader can understand them.
Yeah.
They're that simple. So again, second question, very similar. But instead of an apple inside, now it's a helium balloon inside.
Okay.
So out of these 3 trucks, which one is at rest?
B.
Yeah, it is B. For the same reason as the first, because there's no motion.
Yeah.
Right? Which one is accelerating forward?
A.
Okay, let me help you guys out real quick with this one. So a helium balloon is buoyant because it floats in air, right?
Yeah.
This ball here is also buoyant because it's floating in water.
Yeah.
Obviously right now it's at rest, it's vertical, but I'm going to accelerate it and pay attention what direction it goes.
What?
Did you see what happened?
Yeah.
Yeah, so out of these three, which one's accelerating forward?
C.
It is C, yeah. Now there's two reasons why that happens. Do you guys happen to know why?
Because of the buoyancy.
Yes, there's a density difference between the air and the helium. The helium is less dense than the air. What's the second reason?
Is it because it's on the bottom?
No. So it has to do with a force. So as soon as I applied a force in this direction, when the truck accelerates in this direction, all the air that's inside of the truck is also being forced in that same direction through space, because air is more dense than helium, is able to push it along with it in the direction of force. The apple is more dense than the air, so the air cannot push the apple. So the apple just gets left behind. So again, you need a force to have that displacement of the apple and the helium. But only the helium is being forced forward. The apple's not. The apple's just being left behind. So here, I recreated this experiment in real life, and I want to see if you guys can get it. So this is the true "Are you smarter than a fifth grader" question. So again, it's both questions in one. So there's a helium balloon and an apple inside this cargo van. What direction did it accelerate this van? To the right or to the left?
To the right.
To the right.
Yeah, exactly. Because that's the direction the air was being forced, and that's the direction the balloon got forced.
Yeah.
You know, again, the apple just got left behind. So here's a bonus question. It looks like the balloon and the apple are moving away from each other, right? That's what it looks like, that they're moving away from each other. But in reality, only one is being forced away from the other. So only one is moving away from the other. So out of the apple and the helium balloon,
No, it's
it's the balloon.
Damn it.
You got it. Because the apple, again, it just remained in its position. So the balloon got forced away from the apple. Exactly.
Because the apple's staying where it was.
Yes.
That's what I was gonna say. It's just like
you jumped ahead.
Said the wrong thing.
Yeah,
All right.
yeah.
All right, one last question before you guys go. If I have a helium balloon and an apple here on Earth, right, and I release them both, we can see that the balloon goes up and the apple goes down, right?
Yeah.
So it looks like they're moving away from each other as well, right?
Right.
But in reality, only one is being forced away from the other, just like this experiment. So out of the helium balloon and the apple, which one's being forced away from the other? Which one's moving away from the other?
The apple.
No,
It's
actually,
the helium balloon.
It's the helium balloon as well.
Wait, why?
Yeah.
Because isn't the force of gravity acting on the apple?
So I don't know if you guys knew, gravity as a pulling force is just a theory. So it has never been proven or measured or detected. So it doesn't exist. Yes. So the real force of the Earth is not a downwards pull, is an upwards push. So the Earth is pushing up against your feet right now, not pulling you down towards it.
Yeah.
Yeah, so that upwards push of the Earth is what's pushing up the air, creating the air pressure, and that's why air is able to push up a helium balloon. The apple just gets left behind when it's in free fall, and the Earth crashes into the apple. So here's the real reason why I'm doing this before you guys go. You guys believe the Earth is a ball, right? Yeah, right? You guys understand that on a ball, up is relative. So if you're standing here, up is this way, but if you're standing here, up is this way. And every direction away from the center is up on a ball. If we could prove physically that gravity is not a downwards pull, but in fact is an upwards push of the Earth, how can the Earth push up in every direction at the same time if it was a ball?
You're trying to say that the Earth is flat?
Not necessarily flat, but I'm getting there. So that would mean the Earth will have to be expanding in order to be able to push up in every direction if it was a ball. So it just explode, it wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in gravity being a pull of the Earth. Because if we could prove that it's an upwards push instead, the whole ball Earth and heliocentric model would just fall apart. So the fact is the Earth is just an extended level plane, and it's pushing up in one direction. So up is not relative, it's singular. So everybody's up is the same. So China and Australia are not bending down under your feet. They're just across the way. Every continent and place here on Earth is just across the way.
Yeah.
We're all on the same level, in other words. So that will be the number one proof.
Say that the Earth is not like a sphere.
It's not a sphere, it's a level plane. So that will be the number one proof to debunk the globe, is the fact that gravity is an upwards push, not a downwards pull.
Oh, I thought you were saying it the other way. Like, since the Earth is a sphere, then that means gravity must be a downward pull.
Well, it would have to be.
Right.
But physics shows that it's an upwards push. And objects don't accelerate down to the Earth because it's the Earth that's constantly moving up right now. So when I release this, the Earth crashes into this ball. The ball doesn't crash into the Earth.
Yeah.
So the Earth is moving up like an elevator, pretty much. So if I was to ask you guys respectfully before you go, why do you guys believe the Earth is a ball?
Just like scientific, like I feel like it's been proved scientifically.
How did they
If
prove
I
it?
get, you ever seen that experiment where that guy gets like a poster and he puts a hole through it and he puts the level thing like 20 feet away or something?
It's
Or
like,
like 20.
it's like mile. It's like a
Yeah,
mile away.
something like that.
Yeah.
And it's like different levels.
Okay, so you're talking about like a laser experiment through a hole, right?
Mhm.
They elevate a hole above the water, and at the other end, they put it at the same elevation, and they shine a laser through it, right? And
Yeah.
it doesn't go through the hole. So here's the thing: if I shine a laser through water, will that laser go straight?
No, it's refracted.
Exactly. There's refraction. So the air, the moisture here on Earth, it's gonna refract any laser that you shine through it. So you're always gonna have an inconclusive measurement when you're using lasers. There is a better way to measure for the Earth's curvature, though, which will show there is no curvature. But first, do you guys know the radius of the Earth to know how much curvature there should be?
I've got no idea what the
No worries.
radius is.
No worries.
We really gotta go take my ID picture.
I mean, real quick, just to take a minute. So the radius of the Earth is 3,959 miles. That's what they tell us. So based on the radius of the Earth, there should be 8 inches per mile square of curvature, which means there should be 8 inches of curve in the first mile, 32 inches in the second mile, and 6 feet of curvature in the third mile. So how do we measure for that curve, right, to see if it's actually there? So if we went out to a giant lake that was 3 miles across, filled with water, when the water's at rest, and if we build a level structure above that body of water, the surface of that water is going to be parallel to anything horizontal, because that's the physics of water when contained and at rest. It takes the shape of the container, but the surface always equalizes to a level which is horizontal. Just like every surface of a pool is going to be horizontal, regardless of distance, right? They're trying to tell us that every surface of every lake...
No, that's because that's different how volume works. They actually discovered that in the ocean, there are certain like topographical differences on the surface of waves that they can use to measure.
Are you talking about the tides?
No, I'm not talking about the tides. So you know in the ocean how there's different like underwater valleys and like crevices. They've discovered there's like mountains down there, and they've discovered that actually the waves have slight different variations along ridges of these underwater mountain ranges. So that's not actually true. That's because of volume in a uniform.
The water's not at rest though in these situations, right? It's
no,
obviously
but
waves.
if it would be at rest, it would have those like
a hump, you think?
Yeah, that's what they have been studying and observing. So like obviously at rest, if you have uniform volume, that's different. But like that's not.
But
reality.
you know that here on Earth, there's lakes that are even 100 miles long, right?
Okay.
So based on the curvature of the Earth, they tell us those lakes should have like a mile of curvature, which they don't, because obviously lakes are just still water, right? There should be that curvature that should be measurable, but it's not. Every lake on Earth here will show that the Earth doesn't have that curvature that they claim, based on the radius they're telling us.
But like relative to the size of the planet.
Well, again, what they're telling us is 3,959 miles.
All right, we actually really have
But
to
yeah,
go.
no
I'm
worries,
sorry.
man. Here's my channel. You guys can share it. You guys can
Nice.
check me out, and yeah, I go to other universities
If
as
you
well
were
to talk.
brainwashed, would you want to do? Fired.
Right.
Okay.
All right, man.
Level-headed William and that.
You could take that with you.
I'm probably gonna. I'll scan it right here. I'm
Yeah,
just.
sure.
I don't want to carry it. That's all.
Fair enough. No worries. All right, you guys take care.
Have a good day.
Yeah, you too. All right, let me just read some questions. I know I was gonna do that, but I just said hi to everyone. Sounds good. Sounds good. The most projected religion ever. It is. Yeah, the globe Earth, the heliocentric model. Yeah, it is the most protected religion ever. Because even Christians, even Muslims, even Buddhists, you know, even all these people that are part of other religions, right? They all believe the Earth is a ball, or most. I'm not gonna say all, obviously. I'm sure there's people that in every religion that don't accept the ball Earth, but most of the people in these religions also believe in the heliocentric model. So the heliocentric model religion encompasses all these other religions, making it the biggest religion on Earth. And because it's the easiest to debunk, that's why it's the most protected, in my opinion. So yeah, the heliocentric model is the most protected religion on Earth by far. And how do they protect it? Again, censoring information, you know, censoring channels like myself, you know, censoring anyone speaking against it. You know, they completely get shadow banned and just fucking put to the side, right? They'll remove views from your videos, they'll remove subscribers, they'll use every dirty trick in the book to try and suppress this information, again, and they're doing it, doing it as we speak, you know, and that's the reality. But yeah, I agree with that. Let me see. It's like me reading a brain surgery book and remembering certain words and phrases and regurgitating them in stutters and erms. No, yeah, that's what the, you know, most globe Earth believers, I guess you could say, especially people that study astrophysics and all that shit, astrology or whatever. I think that's just to do with science, but yeah. Yeah, they just repeat certain words and phrases thinking that it proves something. You know, so yeah. We can only go by what physics shows. No point in coming up with explanations for something that we don't know. If we did that, we'd be no different from the religious types. Yeah, I agree with that. Again, when it comes to the luminaries, for example, well, why does this happen? Why do we have a lunar eclipse? And why do we have eclipses? And why do we have crescent moons and stuff like that? And it's like, I mean, first of all, that's irrelevant to the shape of the Earth. It's not going to prove either or, whatever is the true cause of that, right? Second, they're using these explanations that the globe Earth comes up with, for example, to reinforce their model, to reinforce their beliefs. In other words, they're using it as some kind of proof that it is a globe, because I'm explaining that the shadow on the moon, it's the Earth's shadow and it's curved. So therefore, the Earth must be a globe, right? That's the logic behind it again. But they have to make assumptions about what these actually are, what these phenomena actually are, which in reality nobody knows. We can only make assumptions and theories about what it is, which, again, it's fine to do that. All religions, I'm sure, have done that since the beginning of time. Try to explain what the sky is doing, right? The sun, the moon, and the stars. I'm sure people have wondered what it actually is since the beginning of time, right? So again, making assumptions of what is going on is irrelevant to the shape of the Earth. And again, you're only making an assumption at the end of the day anyway. You know, but because it reinforces them a little model they created, you know, it must be true now. So that is what's happening. Again, it's just having a bias and just buying into these claims, you know, baseless claims, again, to just defend their belief. You know, that's basically what it is. You know, that's any other religion or any other cult member that has someone go against their beliefs is gonna come up with explanations and unreasonable fucking conclusions to defend their beliefs. You know, religious people are some of the most unreasonable people you can ever speak to. And again, I'm not saying that to offend anyone. I'm not saying that to spread hate. I'm just saying that based on experience. You know, I've spoken to a lot of religious people and they are tunnel vision. Literally, when you speak to someone that's religious and they're talking about their religion, they're just tunnel vision. They're so unreasonable that it's just a headache to continue the conversation, because they don't listen. They don't apply logic consistently all around. You know, they cherry pick things to fit their belief, which again, these things that they cherry pick are nothing to do with physics anyway. You know, they're talking about fucking stories that happened thousands of years ago and shit like that, and what, you know, it's so bad. It's just so bad that it's just hard to have an intellectual conversation with a religious person. And I hate to say it, the globe earthers are no different. You know, they just start cherry picking, you know, illogical stuff to reinforce their model, and then start talking about people thousands of years ago as well that proved this somehow with sticks and shadows, right? And it's just so bad that it has nothing to do with physics and natural science, which can be measurable, testable, and repeatable by anyone here on Earth. Because that's what science is about. It's the method to be able to prove things to yourself. Again, you don't need to just have faith and belief when we're talking about science, real natural science. You know, which all globe earthers do have beliefs. that have nothing to do with natural science, which cannot be recreated, demonstrated, or shown in any practical way. But yeah, they want to be taken serious. You know, it's like, again, they're tunnel vision as well. Most religions or most religious people are just tunnel vision when it comes to proving their beliefs. You know, they're not open-minded. That's for sure. You know, and I'm not saying everyone is like that, but the majority is. You know, and obviously it's just how we were trained. It was just how we were brought up, you know, at the end of the day. And it's unfortunate. It sucks, you know. So that's why I'm out here, to try and break that cycle. I'm trying to break that cycle of just conformity and obedience. You know, I want people to be independent, critical thinkers. I want people to use their common sense, especially if someone's making a claim that contradicts that. What we already know, what can be proven, you know. So again, for the people that are new to this and stuff, gravity, right? Really quick, this is an accelerometer, this container filled with water. Why? Because when it's at rest, obviously the water's level, right? It remains level, right? But as soon as I apply a force in this direction, for example, the water displaces relative to the direction I apply the force. If I apply it in that direction, the water displaces to the back, right? If I go this direction, the water displaces to the back of that direction, right? Even when I accelerate it down, the water displaces to the top. So the water will always displace in the opposite direction of the applied force when water is contained, right? Which again, on Earth, is being displaced down because the force is up. Simple, right? But globe earthers want to say that in free fall, there is no displacement of water, you know. They're saying that gravity accelerates all the matter down equally. So it's grabbing the bottle and the water at the same time and then accelerating them together. That's why there's no displacement. So based on that claim, in other words, that's why accelerometers don't detect acceleration as well, because an accelerometer, like in your phone, there's components inside your phone that displace relative to the direction you move the force, or you force the phone, right? They're saying that, oh, it doesn't detect that acceleration either, the accelerometer on your phone, because everything's being accelerated together. So there is no displacement, right? So again, that's like claiming to recreate gravity, you would have to be able to accelerate this in a horizontal vector without the water displacing. So imagine accelerating this without the water moving or swishing. In other words, displacing. That's physically impossible to do. To be able to accelerate this container in any direction, well, in the horizontal vector, because that will be recreating gravity, without that happening, without the water displacing. Now imagine accelerating this from being at rest and the water remains level. Holy shit, that would break physics as we know it. Literally would break physics as we know it. But that's what the globe earthers want you to believe. That gravity is able to grab all the matter together and accelerate it without any displacement. Because that's what gravity claims is doing, the pulling force of gravity in free fall. Because that's their explanation to why there is no displacement and no detectable acceleration. And I don't know why I use quotes right there, because there is no detectable acceleration in free fall, right? But that's the literal claim that they're making, which completely defies physics. You know. Yo, what's up? Yeah, I am. All right. 2 very easy questions, multiple choice, just to see if you can get them.
Sounds good.
All right, so here I have 3 box trucks.
Yeah.
They're completely sealed. They're all on a level surface,
Yeah.
and they all have an apple inside hanging from a string.
Okay.
The only difference between these 3 trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So
Yeah.
out of these 3 trucks, which one is at rest?
This one?
Yes. How'd you know it was me?
Because when you move forward, there's like this is the positive direction, so you have it's just like physics, I guess.
Yeah, because there's no motion of the apple. It's just
like,
remaining
there's no
vertical.
force going this way.
Yeah, exactly.
Yeah.
Okay, which one is accelerating forward? Which one is going this way? Which truck?
Yeah, assuming this way is like forward, this way is backwards.
Yes. Which truck is going forward?
You just think this one, right?
Yeah, it is A. How'd you know it was A?
Because as you move forward, then you have forces on the like pendulum going backwards.
Yeah, well, it's not a force necessarily; it's inertia. So
Yeah.
the apple remains in its position due to inertia, and the truck moves forward, and the apple just gets left behind.
Yeah.
You know. So yeah, you got it. Perfect.
Okay.
So the second one, pretty similar, but instead of an apple, it's a helium balloon inside now. So out of these three trucks, which one is at rest? Yeah, and it's for the same reason as the first, because there's no motion,
Yeah.
staying vertical. Which truck is accelerating forward?
I mean, I don't know much about helium.
Okay, let me help you out with this one, because a lot of
Yeah.
people haven't seen this experiment before.
Yeah.
But look,
And
a
you
helium
assume it's
balloon
Yeah.
is buoyant, right? It floats in air. This ball is also buoyant because it's floating in water. So this ball represents the balloon.
Yeah.
So right now it's at rest, it's vertical, but I'm gonna accelerate it this way, and I want you to pay attention what direction the ball goes. Did you see?
Yeah, so it's falling this way, and then once you stop it, it's falling back.
Yeah, so which one's accelerating forward?
So this one.
It is C. So
Ooh,
there is
that's
two.
crazy.
Yeah. So there's two reasons why this happens. Do you happen to know why?
No, I don't think I did.
Yeah,
Maybe
so-
because the air in here, like the force in here, is pushing it down.
That is one of the reasons. That
Yeah.
air is pushing it forward.
Yeah.
And the second reason is there's a density difference. The air is more dense than the balloon.
Oh, okay.
Yeah. So because when I apply a force in this direction, all of the air that's inside of the truck is also being forced in that direction through space. And because air is more dense than helium, is able to
Yeah.
push it along with it.
Okay.
The apple obviously is more dense than the air, so the air can't push the apple. So the apple just gets left behind. Yeah, so you get the opposite effect with this one. So yeah, you got it. So here, I recreated this experiment in real life, and it's both questions in one. So I want to see if you can get this one. This is a true, are you smarter than a fifth grader?
Okay.
Yeah, so it's both questions in one. So here, helium balloon and apple inside a cargo van. What direction did it accelerate this cargo van, right or left?
Positive.
Yeah, exactly, this way, because obviously that's the air that's the direction the air was being forced, and the balloon got forced in that direction.
Yeah.
The apple just got left behind. All right, perfect. So, bonus question, real quick. It looks like the apple and the helium balloon are moving away from each other, right? That's what it looks like.
Yeah.
But in reality, only one is moving away from the other. In other words, only one is being forced away from the other. So, out of the helium balloon and the apple, which one is being forced away from the other?
Well, you said the force of like the air pushes it, so you assume it's the balloon. It's just inertia.
Yeah.
So the balloon's getting forced in the apple just in motion.
It's just being left behind.
Yeah.
Yeah, so you got it. So the balloon is being forced away from the apple. So the balloon's moving away from the apple's not moving away from the balloon.
Yeah.
The apple just remained in its position and got left behind.
Yeah.
All right, you got it. Perfect. One last question before you go.
Sure.
If I have a helium balloon and an apple here on Earth and I release them both, we can see that the helium balloon goes up and the apple goes down, right?
Yeah.
It looks like they move away from each other as well,
Yeah.
but in reality, only one is being forced away from the other. So out of the helium balloon and the apple here on Earth, which one is being forced away from the other?
The apple being forced down by gravity.
Okay,
Because,
so-
like you have your force, right?
Well, the reality is the balloon is being forced away from the apple. And how do we know that? I don't know if you knew, the pulling force of gravity has never been proven or measured, so it's just a theory. I don't know if you knew gravity as a pulling force is just a theory. Again, because it's never been measured or detected. In other words, it doesn't exist. So the real force of the Earth is not a downwards pull, it's an upwards push. So right now the Earth is pushing up against your feet, not pulling you down.
Yeah. Oh,
so
yeah.
that
Like force normal.
The normal force,
Yeah.
exactly. That's the only real force that exists.
Yeah.
But that means that the Earth is pushing up against your feet, which is pushing up the air, and that creates the air pressure here, and that's why air is able to push up a helium balloon. So an apple doesn't actually move down to the Earth; it's the Earth that moves up to the apple. So the apple is just being left behind.
Yeah.
So that's the reality. So the Earth is literally pushing up like an elevator right now, and that's what gravity is. It's an upwards push of the Earth, not a downwards pull. All right. So, real quick, you believe the Earth is a ball, right? This is the
Yeah,
real reason
of
why I'm
course.
doing this.
Yeah, yeah.
So on a ball, up is relative. I don't know if you knew that. So if you're standing here, up is this way, but if you're standing here, up is this way. And every direction away from the center is up.
Yeah.
If we could prove physically that the force of the Earth is an upwards push and not a downwards pull, how can the Earth push up in every direction at the same time if it was a ball?
Because it's wait, say it again.
So if we could prove that the force of the Earth is an upwards push and not a downwards pull, how can the Earth push up in every direction at the same time if it was a ball? Because up is relative.
Oh, because each point, like on the Earth, like has its own force. I guess like has its own force normal. So,
Yeah.
Like the force normal here is different than the force normal there, and like that's what's pushing you, not like the sphere is its whole. It's like each part, I guess, or something like that.
Well, the reality is because when you release an object into FIFA, this doesn't move down to the Earth through space. It's the Earth that's literally moving up through space.
Yeah.
So if the Earth was moving up through space and it was a ball, that would mean the Earth would have to be expanding to be able to move up or push up in every direction. That would mean the Earth would just explode. It wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in gravity being a pull of the Earth. Because if we could prove that it's an upwards push, the whole heliocentric model would just fall apart. So you have to believe in a pulling force of gravity first, which could easily be debunked. So the fact is, the Earth is just an extended level plane that's pushing up in one direction. So the Earth is just moving up in one direction at a time.
Are you sure 5th graders know this?
Oh, once I explained, I've done 6th graders here at this university as well. And once I explain buoyancy and what's required for buoyancy, they completely get it. Yeah, because once you know this stuff, you can't unknow it.
Once you know, but
so
freehand.
Exactly. So a helium balloon rises because there's air pressure here, but the air's being forced up because that's the direction the balloon's being forced as well. So what's creating that force? Well, it's the literal Earth itself. So something in free fall, there's no detectable force forcing this down because this is not moving down. It's just being left behind from the true force or motion of the Earth, which is up. So it's literally that simple. So before you go real quick.
I gotta hit a presentation.
I no worries. So I mean, why do you believe the Earth is a ball? Just leave me with that.
Because fixtures, of course. Like, I don't know, like when like the curvature of the Earth, like everything.
Okay, if I showed you a picture of me flying, for example, do you believe I could fly?
Are you trying to tell me the Earth is flat?
It's a level plane, 100%. And again, the upwards push of the Earth debunks the globe Earth because you can't have a push Earth pushing up if it was a ball. It would tear itself apart.
Nah, but it's like Alright, maybe I'll come back.
No worries, man.
But,
Here's my channel. If you don't come back, you can check me out. I can talk to other people and other universities as well. You can take it with you. Sure. Yeah, you can take that.
Alright,
I know, man. Thanks for the chat.
Good to meet you. I'm Leo.
Yeah, William.
Alright, for sure.
Nice to meet you, man.
Maybe I'll come back.
Yeah.
Maybe with some birds.
Fair enough. Mr. Cheswick, if you want to get to the top, get a nap, drink piss, do a few grapes, and sell some Miracle Health. Oh man, I can't even see the rest. Can I remove that? Some Miracle Health products. Oh man, I have to check my phone now. Time is 1:49. All right. We'll wait another 10 to 15 minutes. Another group coming. This will be the last one. What's up? What's up? All right. All right. 2 very easy multiple choice questions. Okay. We'll start with the first one here. So here I have 3 box trucks. They're completely sealed. They're all on a level surface, and they all have an apple inside hanging from a string. Okay. The only difference between these 3 trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
It's B, right? Yeah, don't mess this one up.
Yeah, it is B. How'd you know it was B?
Because it's at rest?
Yeah, it's not moving.
Yeah.
It's not moving. Perfect. Which one is accelerating forward?
A.
Okay, how'd you know it was A?
Because inertia.
It's resisting its change.
Yes, it's resisting the change due to inertia. So the apple's being left behind because it's able to resist the change. Perfect, you got it. The second one, pretty similar, but instead of an apple, is a helium balloon. So out of these 3, which one is at rest?
B still.
Yes, it's for the same reason as the first, because there's no motion, there's no change. All right. So which one is accelerating forward?
I would say A.
C.
Okay, C. Okay, why would you say C?
It's like so light that the balloon, so it's not gonna notice. Like the
It's
air.
A.
Just,
I think it's A, bro.
I'm gonna go with C.
Okay.
Okay. I honestly,
It's A.
I think it could be C. Something to do with like
Okay, let me. A lot of people haven't seen this experiment before, so I'm going to show you guys. So, this is a buoyant object because it's lighter than air, right?
Yeah.
This is also a buoyant object because it's lighter than the water.
Yeah.
So this ball represents the balloon. So right now it's at rest. Pay attention. I'm going to accelerate it this way. See what direction it goes.
Oh, you got it. Okay, but I don't know if a fifth grader knows that.
No, but once you show them, they won't. It's pretty simple to understand.
Yeah, it makes sense. I just wasn't sure.
Yeah.
I like that.
So it is C. So there is two reasons why that happens. You happen to know why? What are the two reasons?
Well, is it because helium is lighter than air?
That's the first reason. What's the second reason?
Because there's something to do with the pressure.
This has to do with force, exactly, a push. So as soon as I apply the force in this direction, all of the air that's inside the truck is also being forced or pushed in the same direction as the truck's moving. And because air, the air is able to push the helium balloon in the direction of force, because it can't push the apple because the apple has more inertia to resist the air. Yeah, so the apple just gets left behind. You got it. So here, I recreated this experiment in real life, so it's both questions in one. So I want to see if you were smarter than a fifth grader now. Sixth graders can get this, you know. So here, a helium balloon and apple. What direction did it accelerate? Right?
Yeah.
This way, yeah, you guys got it. Because that's the direction that the applied force was.
That is pretty sick.
Yeah. So here's a bonus question. It looks like the apple and the helium balloon are moving away from each other. That's what it looks like, right? But in reality, only one is being forced away from the other. Only one is moving away.
No, the balloon.
The balloon. The apple's staying. It's resisting.
Oh, you're right. Okay.
So in reality, the apple is staying in place. So the helium balloon is the only thing moving away from the apple.
Yeah.
So that's what's happening. That's in reality. So here's one last question before you guys go.
Okay.
If I have a helium balloon and an apple here on Earth, right, and I release them both, we can see that the balloon goes up and the apple goes down, right? So it looks like they move away from each other as well. But in reality, only one is being forced away from the other. So out of the helium balloon and apple here on Earth, which one is moving away from the other? Which one's being forced?
The apple has the force of gravity on it.
What do you think?
Which one is moving away from the other?
Which one's being forced away from the other?
I want the force because of gravity.
I think it's the apple.
Yeah.
Just because gravity is forcing
Gravity.
it out.
The balloon's just moving because of the pressure.
Or we're all just actually stupid.
The reality is the balloon that's moving away.
Okay.
So, and I'm gonna explain to you guys why we know that. So I don't know if you guys knew the pulling force of gravity is just a theory. So it actually has never been measured, detected, or proven. So in other words, it doesn't exist. That's because the force of the Earth is actually an upwards push. It's not a downwards pull. So right now the Earth is pushing up against your feet. It's not pulling you down towards it. So
it's just pushing up against the balloon.
Yeah, so it's not necessarily pushing the balloon. It's pushing the air, and then the air is able to push up the balloon.
Okay.
So when something is in free fall, it just gets left behind. It doesn't get forced down. It's the Earth. It's the Earth that literally crashes into free falling objects. Because the Earth is literally moving up like an elevator right now. So that's the real force of the Earth. It's the upwards push of the Earth. So this is the real reason why I'm doing this, though. You guys believe the Earth is a ball, right?
Yeah.
Do you guys understand that on a ball, up is relative? So if you're standing here, up is this way, but if you're standing down here, up is this way, right? In every direction away from the center is up on a ball because it's relative. If we could prove physically that the force of the Earth is not a downwards pull, but in fact it's an upwards push of the Earth, and physics shows us that, how can the Earth push up in every direction at the same time if it was a ball?
Is it because it's expanding?
It would have to be expanding, but it's not expanding. It would just explode. It wouldn't work, exactly. So that would mean that in order for people to believe in the ball Earth theory, you have to believe in the pulling force of gravity, because if we could prove that it's the other way around and it's pushing up, then the whole heliocentric model, the ball Earth, will fall apart. It wouldn't work. So the fact is, the Earth is just an extended level plane that's pushing up in one direction. So everybody,
flat Earth?
Not flat Earth, level Earth. So the flat Earth is a psyop as well, and I'm gonna tell you why. Over 95% of flat Earthers deny the upward push of the Earth. They also believe that objects accelerate down in free fall.
My question is,
it's the other way around.
What is proving? And I just don't know. So that's why I'm asking. What is proving that the Earth is pushing up? Because gravity is obviously, that's a theory. And right, so is this not just another theory?
No. So the normal force of the Earth, I don't know if you guys heard of the normal force of the Earth. It's an upwards push because buoyancy is a force. So when an air bubble rises through water or anything, like a beach ball, when you try to submerge it, there's an upwards push. Yes, so that's a real force that can be measured by and detected. A downwards pull of gravity, when you release something into free fall, that downwards force cannot be detected because this only falls due to inertia, the resistance. So the air's not dense enough to push an apple in free fall.
But if you put like two things in space, and they go together.
Well, that's what they say. Now we're talking about a place that we've never been to, and then again, they're just making claims.
Space you've never been to.
Yeah, nobody's ever been to outer space.
Outer
space is a concept.
But there has been tests in a vacuum in which the items fall down.
Yes, they fall down at the same rate. Yes, that's because there's no air resistance trying to push. So a feather and a bowling ball, when there's air,
obviously there's no air resistance. That's my point. But
because they both lose momentum at the same rate.
Prove one or the other. Both.
No, here's another way we could prove there is no downwards force. So everybody's smartphone, I'm sure you guys have one, has a built-in accelerometer, which is a force detection device, pretty much.
Yeah.
So when you download an accelerometer app to measure for force, and you have your cell phone here at rest on Earth, it will detect 1G force. Wow, when you move that accelerometer from being at rest, in other words, accelerate it in any direction, left, right, up, down, it detects an increase in G-force because you're accelerating. It detects that change, right?
Yep.
When you put that phone into free fall, though, from being at rest, exactly.
Yeah.
It doesn't detect the acceleration down because there is no force down.
So what is your proposed?
I think the force is already being acted upon and it is accelerating.
No, because then the accelerometer would detect that change in acceleration down. 9.8 meters per second is really fast. It's 27 miles per hour in 1 second.
Yeah.
Which, imagine being in a car and going from 0 to 27 miles an hour in 1 second. You're gonna feel that force.
Right, but if you're standing on the other side of the wall of the car, you could stand on it 27 miles per hour in 1 second.
I'm curious to what you're saying. So you're saying it's all flat?
Level. The Earth is a level extended plane.
So therefore, is it flat, or is there something below
No, because you could have a flat wall, right?
Yeah.
That doesn't mean that the wall is level. So the Earth is level because it's perpendicular to the force of the Earth, which is a vertical force, but it's up, not down. So it's level perpendicular to the force.
So I guess I hear what you're saying, but I just don't get what you're proposing. Like, what does the Earth look like? It's just like a table, and there's
it's an extended level plane that's pushing up, like an elevator, pretty much.
Oh, it's just like a.
And we're resisting the change.
Yes, because we have all mass has inertia. Exactly.
Sure. Yeah.
And that's why we have weight, because we're resisting that upwards motion, that upwards change.
Then explain like, what satellites are doing. If they're circulating the Earth on multiple directions.
Exactly.
How do we have this footage? How do we have the maps, though?
So, let me show you this real quick. So, images of the Earth from outer space, that's where it's going, right? Pretty much.
Yeah.
So these are official NASA images from 2002 and 2012, and they admit that they don't have real photographs of the Earth from outer space. These are all CGI, in other words. And they admit that. So, I mean,
do? Where?
In their website, you can look it up. They're all composites. They say
CGI enhanced.
Sure, they use word trickery to try and like downplay it. But at the end of the day, even if they claim they were real, these images defy physics. So if I showed you an image of me flying, would you believe I could fly?
Yes.
You would believe I could fly?
I would say what are we talking about flying? I mean, you can go to an airplane, you can fly.
No, just me flying like Superman. Like flying around a building.
No.
Or even if I showed you a video of me flying around a building, would you believe I could fly?
No, probably not.
No, that defies physics. My point is,
unless you could have like the Iron Man suit or something.
But then you're using propulsion now to do
right.
To do
Yeah.
What does NASA? What does all these scientists? What do they gain by lying about satellites? By saying the world's like a circle? Because obviously, if
why are they lying about
set in this very flat Earth? What's your wording?
Level
Earth.
Yes.
What are they gaining by telling us a lie?
So why are they lying to us about this? Right? So the ultimate reason why I think the people that are pushing this are lying is basically to stump our critical thinking skills, so that we just obey authority over our own common sense. So that again, it's just to control us. It's to dumb us down. To put it in simple terms.
That doesn't follow through. Honestly, I don't know if
that's fine. The motive behind the lie has nothing to do with the actual lie
I would
itself.
examine all the science.
Exactly. Then you could once you establish there is a lie, then we can start looking at what is the motive for this lie.
Is this a widely thought of thing? Is this a you on your own thing?
This is on my own. I'm doing this on my own. Obviously, there's plenty of people that realize this as well, but this is the #1 censored topic online by far. There's nothing else that comes close to this. So this is so censored that I have to come out in the real world to speak to real people, because otherwise my channel would not get recommended.
What are your credentials for like getting here and like learning?
At the end of the day, we're all scientists, because we all can experience the Earth and we can all test the Earth and the matter, how matter behaves.
I'm not saying that anyone's.
So I don't need credentials. I just need to have common sense and critical thinking.
But there are people who have.
Could they be bought out? People with credentials.
So wait, what's your education background?
That's my question.
Just high school. Yeah, I didn't even go to university. Yeah, I would say people that go to universities get more indoctrinated, and it's more hard to get through people like that. But again, no offense to anyone, but just as my opinion, I feel like if you go to university, that doesn't prove anything.
I turned down university.
Yeah, actually,
yeah.
You know, at the end of the day. But again, if you want to learn financing, you know, and stuff like that, then it's cool, right? But when we're talking about natural physics of the Earth, the natural science that proves that the Earth is level,
I
then
guess this question
you
was,
don't need to
where
go
do
to
you
school.
get your knowledge of this natural physics?
From reality, how matter behaves.
So you studied the physics of the
Yeah, I
world.
did test myself. I have like over 11 experiments on my channel. You guys can check it out after you leave.
Yeah, what's
That'd
your
be-
channel?
Here, I'll give you guys my
My
channel
one
right
qualm
now.
with this model is
Yeah,
you're
here.
giving information to people who aren't
You guys can take that.
as educated. I feel like I would love to hear someone who's like a professor talk to you about this.
I've spoken to professors, physics professors
Yeah?
too. Yeah.
And what have they said?
Nothing more than you guys can say. He just believes it too. He
Okay,
told me to
but-
show him numbers, and I showed him numbers. You guys want to know the numbers that debunk
You
the
do
globe as
agree
well?
that this, I mean, I know obviously like prove the point, but this could just be the scale of the Earth, is why it appears this way, yes?
They've also proved that
yeah,
the
it's why
Earth
it
is
appears
curved.
horizontal. Is what
Yeah.
you're saying?
Yeah,
I mean,
yeah.
sure, yeah, but here's the
What
thing,
about
though.
that experiment in the 90s that
Based
proved
on the-
that there's a curvature of
Okay,
the Earth?
here's how we
It's
prove
not
there is no curve of the Earth. Do you guys know the radius of the Earth by any chance?
No.
So that way we know how much curvature there should be, right?
Yeah.
So to measure. So they tell us that the radius of the Earth is 3,959 miles, which is the distance from the center to the outer circumference. So based on the radius they're telling us, and using the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile based on the radius they tell us. And it turns out there should be 8 inches per mile squared. That means in the first mile there should be an 8-inch curve, second mile 32 inches, and by the third mile there should be 6 feet of curvature. And in 10 miles there should be 66 feet. That's just, it's a 6-story building.
Yeah.
So how do we measure for that curve, right? To see if it's actually there. Easy. If we went out to a giant lake that was 3 miles across, for example, filled
It
with
should be
water.
5 feet down.
Yeah, no, and we build a level structure above that body of water on
Yeah.
the lake. When the water's at rest, it's going to be parallel to anything horizontal above it because that's the physics of water. It takes the shape of the container, but the surface always equalizes to a level which is horizontal. They're trying to tell us that every lake on Earth is bending 8 inches per mile squared, which will be 6 feet deviation from the level in 3 miles. Which that defies physics. Water doesn't have the physical ability to maintain a shape on the surface.
But if there's gravity, it's warping around.
Again, you have to believe in this pulling force of gravity, which is just a theory.
Which is generally believed by
everything
everyone.
is a theory to an
So
extent.
if everyone I thought children believe in Santa Claus, or it doesn't mean Santa Claus is real. You know what I'm saying?
Right, but if we're talking these theories, it's all a theory to an extent.
No, the upwards force of the Earth, the normal force is what they call it. It's a real force. Again,
Yeah, normal
buoyancy,
force.
Buoyancy is a force.
Yeah, but
Being
they
the
actually
ground.
there's a. I obviously.
But at
this
that
is
point,
not- this
the
is not
ground
my
wouldn't
nature,
be
I'm not gonna
forcing
act
up,
like I
though.
know,
It's just
I'm very
resisting the
educated.
downwards push
But-
in your model.
But gravity is it works in tandem with the normal force. So just relying on one and ignoring the other is illogical.
So
in my opinion.
in your model, you believe in a downwards pull or downwards force, and then the
attraction
Earth,
of objects.
and then the
And the
air,
Earth
and then the
pushes
Earth
back up because
no,
of
it doesn't.
gravity.
It doesn't necessarily push back up. It just resists that push down. So the reality is the other way around. It's the Earth pushing up, and your inertia
But according
resists
to what?
that
I
change.
mean, we're going off of your opinion.
No, that's
versus,
a fact. That's a normal force. It's an upwards. So when you have a beach ball again submerged in water, you could definitely feel a significant amount of force pushing that ball up. What's pushing that ball up?
The fact that there's air
Can I
in
see
it,
the
which
It's
is
the water pushing it up, right?
It's, it's the change in density across.
But what creates that change in density, that change in pressure? Because there's a change in
You
pressure.
can only see about like 3 feet of the
So in order to recreate a pressure gradient, which gives you these effects, you need a container that's pushing in this particular direction. So again, that's the reason why this buoyant object goes forward, because when I accelerate this way, I change the pressure gradient in this direction.
You need a container,
and you need a force. And depending on the direction of force, that's the direction.
I don't know. I don't think you do need a force.
Yeah, because right now the ball's being pushed up, right? But if
Yeah.
I apply a force in this direction, the ball goes this way. If
Right,
I apply
yeah,
a
the
force
ball
in-
is being pushed up.
Yeah, because I'm changing the pressure gradient inside the container when I go this way.
The pressure gradient inside the container.
Yeah. So right now, what direction's the pressure gradient? It's up.
It's
exactly.
it's
That's
pulling up.
because the Earth is pushing up on it right now.
This is saying
Sure.
it's not
Yeah,
the same.
yeah, that's it's that simple.
Or the Earth could be pulling this down, and then this is trying to resist this water.
Yeah, but if you go to
So if the water's being
this is
pulled
the
down,
same
how can
shit
it
as
push?
this.
How can the water
How
push
the
the
fuck is
ball
this
up?
5,000
The water's
less
being pulled
than
down,
this?
and it's stuck in
This is
here.
the
There's
same
nothing. It's not
distance.
actively moving.
I know, but there is tension on the string because it's being pushed up.
Wait, okay.
Yes, there is tension.
Yeah, just like if I push
This ball's being pushed up.
Oh, okay.
Yeah, this ball's being pushed up right now.
Yeah,
That's why it's buoyant. Buoyant objects go up.
I'm sorry, I can't hear you.
Yeah, buoyant objects go up.
Yep.
because they're being forced up. But right now I have it tied to a string, which is preventing it from hitting the roof of this container.
Yeah.
But there's tension on that string because this ball is being forced up.
Because there's an active, and it's fighting against the pressure. The pressure's causing it to go up.
Yes, the water pressure. So
the water pressure,
yes,
exactly.
What's creating the water pressure of the container?
But then with the map,
What's creating the water pressure of the container?
Yeah, in the container.
It's just the water is it's not as it's denser than air. It's a different material.
Sure, but my point is that in order for water to be able to push up anything in any direction, the water also has to be forced in that same direction to be able to push anything that's less dense than the water.
No, I mean it's just moving up. Yes, it's pushing it in a direction.
But when I force the water in this direction, the water's more dense and is able to push the ball in that direction. So the buoyant object always follows the direction that the water is being forced. In any direction, up, down, left, right. And right now, at rest here on Earth, it shows that it's being forced up. Because that's the direction the buoyant object's being forced. That's the direction the water's pushing it. In free fall, that tension wouldn't be there. If I put this container in free fall, that tension would not be there.
It wouldn't, and that's because there's no gravity here acting on.
Well, I mean, there is. If there is 1G.
When you're dropping, when something's in free fall, Einstein, this is like his thing.
Theory of relativity.
Yeah, when something's in free fall, it's not experiencing any forces on it.
Exactly, but that's because
because either there's gravity, which is already in place, or because the floor is moving upwards.
Yeah, so here's the thing. When you accelerate a container with matter, there's always going to be a pressure change and a displacement of matter inside of it. That's why the apple goes back and the balloon goes forward, right?
Yeah.
In free fall, you have no change. So they have this explanation Einstein came up with to explain why there is no change in free fall, but because they want people to believe in the ball of Earth. That explanation cannot be recreated in a horizontal vector. So I cannot accelerate this container in a horizontal vector without any change happening. The change will always happen.
This is separate. What about like constellation? Like how can I see a constellation here? And also on the other side of the Earth,
you see a different one.
I see you can see the same one because it's based on the Earth is turning. So based on obviously the theory that we have, which is the Earth is circular and the sphere, the spherical. Sorry, you can see the Big Dipper here. And you can see the Big Dipper there.
So the Earth,
all the way over there.
The Earth is not rotating. The sky is rotating. So the stars.
What the fuck?
No. Yeah. So the reason why the stars change above you is not because we're rotating.
Where did the sun
go?
The
sky rotating.
The sky rotates around us.
No, it just rotates. I don't know exactly how it works, but it's the stars that are moving
how do
around
waves
us.
and weather start?
What?
Like waves and weather that starts with like.
Yeah, what determines the?
Is that not the movement of the Earth?
Yeah, it's the moon.
No,
the moon. Sorry,
the sun too. The sun has to move, creating different weather patterns, pretty much with the clouds.
The sun stays.
Well, the sun moves above us too.
So is this? Hold on. Here's my question.
Exactly.
Does this theory?
You believe is the other way around? Because that's what you were told.
So you're back at regressed like thousands of years. We're back at Galileo, pretty much saying.
No. I'm thinking to physics.
So
for example,
here's my question.
A physical measurement of the Earth debunks the globe.
There's obviously flaws with this. We're not smart enough.
What are the flaws though?
This specifically, you can go to a point. You can go to a point on Earth.
Can you explain what this is trying to prove?
That's the curvature of the Earth.
Yeah, I know. So that proves that this curvature is that not?
So based on the curvature of the Earth, it should be 8 inches per mile squared, which should be measurable here on Earth. And these measurements will show there is no curve.
The horizon
based on the
is
physics
measurable.
of water. How do they measure it?
How do you measure it? You would. Okay, so you go to a place really far away and say there's a skyscraper in the distance.
Yeah.
And then you look up and you're not able to see the bottom of the skyscraper.
Yes.
Exactly.
Due to perspective.
Huh?
Due to perspective.
Not if we're all
curvature
even.
of the Earth.
So let me show you how that works.
If we are on a.
So I want to see what the perspective.
So here it is. So we do have spherical eyes. So
These
the
are
angle
angles.
of the angle of light entering our eyes changes the further an object gets away. So what does that mean? We know these parallel lines and these railroads these lines are parallel.
Yep.
But it looks like they converge to a point because that's how we see.
But we don't see them.
We're never that low.
Yeah, we do. We do converge. If you go to a railroad,
they're not.
Well,
touching.
eventually, if it goes further and further,
No, they'd edge towards.
Point
infinity.
being, it looks like it's making a triangle.
It looks like it, but it's not.
It's not exactly.
Yeah.
That's because our eyes see.
But
like that.
it looks like it would make a triangle, but there actually isn't a triangle.
My point is, these lamps, these lights are all the same height as well, but it looks like they're dropping in our horizon. That's because of perspective. The reality they're all the same height.
Things get smaller as further
things
away.
That's exactly due to perspective. Exactly. So a mountain or a building, when it basically goes further and further away, because the light entering our eye, the angle of the bottom of that building can reach our eye because the land or water in front of it is obstructing it. So you're able.
Okay,
land is
it
obstructing
disappears.
because it's curved.
Okay, wait. I have.
So it disappears due to our perspective. Not,
It just
not
doesn't.
a
It just
curve.
So okay, wait.
It just
So if I go to an
evaporates.
airstrip,
No, it
right?
doesn't evaporate.
Like,
It
where's
gets,
my
it gets
Hold on,
converged by
hold on.
a limit of
I have
perspective.
a serious question.
It's
though.
the land blocking it in front of it.
I have a question
That's
that I
basically what it
don't
is.
think this can answer.
Yes.
And that's
But it's not because
at
it's
the
curving.
equators.
It's because the lights can't enter our eyes anymore.
What light?
For the light from under the base of the building.
Yeah.
That
Why can it not? What's stopping the light from reaching
that
our
angle
eyesight?
is not high enough to
The
reach our
angle.
eye.
We're on a plane. I can look at any point,
But look,
unless there's something.
Let
in
me
the
show
way.
you here. Look. So this
If it's
arc,
perfectly flat, then
this
shouldn't we
arc
be able to just see
represents
out?
our eye.
Yeah, we
right?
could
forever.
If we have something above our eye and
Like,
keep
there'd
it at
be
the
no
same
horizon,
altitude,
it'd
simply
just
move
be
it away,
the
what happens
world.
to the
It's
angle in our
Minecraft,
field
like-
of view?
Wouldn't I be able
Starts
to
to drop?
What happens to the angle?
Yeah, of that light entering our eye, it starts to drop in our field of view, and something that's below starts to rise in our field of view until it reaches
You
the
could
eye line.
always see this point.
No, you can't.
Yes, you could.
No.
Yes, if you take a line and it comes out, you can reach every single point.
You could even do this in a computer where you could have an infinite.
You can do
extended
this right
plane.
here. It
No,
shows it
you-
on this paper.
You could do this even in a computer. Have an extended level plane. You will not be able to see forever on that
Yeah,
plane.
zoom in. You will.
Yeah, we don't zoom in with
Yeah,
our
we
eyes.
don't zoom in with our eyes, but theoretically we could.
No, but okay. So
And binoculars increase your perspective, but even binoculars have a limit eventually too.
so then okay.
Look at
let's
the
see.
telescope or something.
Yeah,
Even
they
that
have
has
a
a
limit
limit too.
But you
Okay,
can
telescopes can see things way further than.
Oh, here's
anything on
another
Earth.
thing.
Yeah, exactly.
with
Here's
the
another
building.
thing with the building. If you use binoculars, you'll be able to see the bottom of that building again.
Yeah, because I get
They
to
don't
see
think
Because you're
sure.
in, yeah, 100%. There's a lot of experiments that show that.
And-
When a boat appears to disappear over the curve, people bring out binoculars and they bring it back into view, showing that it's perspective and not going down a curve.
So what you're saying is
So
there's.
thanks for bringing that up. It kind of reminded me of
Okay,
that.
so what you're saying
Yeah.
is there's a blind spot here.
Yes.
There's just an area where this light coming in doesn't
reach your
have
eye.
a path to our eyes,
Yes.
even though there is a theoretical path that I could draw on this line.
Yeah.
And I could draw a million times over.
Yeah, theoretically, sure. If we're just drawing lines on a piece of paper, then yeah, that line should reach your eye.
Right. Or on a plane.
Yeah, but my thing is objects shrink at a
Piece of
point.
paper is
Do you
a
think
plane.
you're gonna be able to
Why-
see it forever?
why
Huh?
it- when
An
you-
object moving away from you
Why
when
when
it
you're-
shrinks at a distance. Do you think you're gonna be able to see it forever?
If you have
Just
perfect
glasses,
eyesight.
but
Yeah.
if it
You
got
will
us-
see- yeah,
If you have perfect
Pause.
eyesight. I don't think we
Can we end
do
this
it.
argument?
Okay,
I have
that's
a
little
question about.
crazy. You think you'll be able to see a quarter 10 miles away?
If you
According
have perfect
to your
sight,
logic,
you wouldn't
yes.
notice.
No, my logic is that there's a limit of how far you can see the angle of
But
view.
if you're a
change.
flat, you're saying it's a flat surface, right?
But my thing is things shrink to a point.
But when we
so
zoom
there's
in
a-
on it,
But when we
Yeah,
zoom
if
in,
you could zoom
if
in
I'm
on it,
here,
maybe
say
you'll
this
be able
is
to see
this.
it.
Okay, but
Wait, say
what's
this
the
is
difference
10
there? Because the
miles,
light
right?
is still coming
You're on this
into
elbow.
the camera from
The
far away.
corner's
The
on this
camera
elbow. If I
isn't
zoom in,
moving.
I can see that,
So the
right?
light should still be coming in. So we should
But
still
that
be
makes
able to
no
see the
sense,
building
'cause
because
it
the light would
curves.
be coming in.
Yeah, but when you're observing a boat or the bottom of a building, that's below your eye line, which there's a change the further it goes out. If something is perfectly aligned with your eyes, then yeah, theoretically sure. But when you're observing a building, the bottom of that building is below your eye line, which there's going to be a change.
It wouldn't be below. So if I squat down and say my eye line is on the floor, it's not below my eye line. The bottom of that building.
It will get obscured even faster because the ground in front is going to obscure that light.
No,
Is that because it
I'm
curves?
slightly.
Yeah, no, not because it curves. That's because our eyes curve.
No,
How does light
do it? The light, yeah, because light reflects, right?
Yeah, it reflects.
So I think you need to. I mean, I can't be convinced until I see
No,
some
I'm
work
not
on
trying to
the light
convince you
entering
guys.
the eye.
But again, going back to measuring the curvature of the Earth, again, a
Yep.
physical measurement of the Earth will prove there is no curvature regardless.
A measurement of the length of the Earth.
Of 3 miles, for example, based on
So
the
yes,
radius of the
how
Earth.
do we measure that?
Again, we go to a giant lake filled with water. Once that
Why a
water's
lake
at rest,
to prove your point?
But don't
because
you
the water,
anything else?
because the ground is uneven.
Also, here's my
The
question:
ground is
how can
uneven.
this falls through? Because then, how can I not just go straight across? If I go from here to Antarctica and then straight line across the Earth, if it's just a level thing, you're not going to get to the other side. You'd have to be going in a circle. You're not. If you could go straight forward.
I have to turn back around to get back.
Yeah, to go east and west, you have to go do circles around the north.
So
Yeah,
I flew to.
So we'll say this is the north, right? And all the continents are just spread out around it. To go east and west, you're simply doing circles around the north, east and west.
But you said it's a flat plane.
Yeah,
So-
this is a flat plane, for example.
So,
And
but in that-
the center,
flat Earth.
Well, flat Earth. Again, you could have a wall.
So,
that's
do you believe in the
flat,
ice
right?
wall?
Does that mean?
No, this is
no,
important.
I don't.
So then, what's on the edge of Antarctica?
I don't know, but I know the Earth is a contained system.
So then, how
regardless.
have people gone across Antarctica in different ways?
How did you prove that? How did you know that?
People have done this. This is not like a. This is
a documented.
people have flown over the Antarctica.
So you could look this up. Nobody has ever done circumnavigation going south and coming back up north. That has never been
They've
documented.
flown from one side of Antarctica to the other.
Yeah,
so
nobody's ever done that.
Is
It's
this
not
the
even-
other way around?
No, but what people have
Yeah,
done,
people
have done
circumnavigation.
east to west, which can be done on a level. Again, the north being the center point.
he's claiming
and
it's in a circle.
Yeah,
but
you're
this
just doing
falls
a circle.
through when
East
people
and
have
west are
flown.
just circles
no,
around
no,
Oh
the
wait,
center
the
point.
circle. You're saying
Yes.
the Earth? Oh, I thought it was like a flat. Oh, it's
No.
a circle
No,
around.
but
That's
can
square.
I,
Not
hold on,
because
hold on,
the
hold on.
Earth rotates east
Can
to
you
west,
stop
it's a
dodging this
shorter
question?
No.
Pause.
I
Can you
mean,
stop
my-
dodging this question? People have gone in Antarctica, like let's say this is it. They've gone from the south side to the north side and the east side to the west side. How is that possible if that's on the outskirts? People have done that. They have not circumnavigated the globe. They went to one side to the other.
Yeah.
How is
Well,
that?
I don't believe in the ice wall being Antarctica. So that patch of ice could simply be another continent somewhere.
But if
Yeah.
your theory is true, there should be ice circling everything.
No, it could be a container that we don't even know what the container looks like.
So I think you need to go like do something and like prove this. Like,
But here's the
you need
thing.
to go into space.
But here's the thing. Your model, what you guys believe in the ball Earth, requires a downward pull of gravity, which can easily be debunked. Because
Then
even
what
they
is
admit
okay?
it's just
Pause.
a
I have
theory.
two fundamental questions.
Buoyancy. You cannot.
theory,
No,
man.
buoyancy is not a theory.
Buoyancy is a theory. You're theorizing, but there could be a million other things. There could be some tiny little person tugging on that ball. Yeah, and that's a theory. And you really,
Yeah, I would agree. That is a theory.
Yeah,
but I don't need
and
that.
buoyancy is also a theory because
No.
you're just making a way to explain it.
In order for matter to move or be forced in a particular direction, you need some other matter to push
And that
it.
would be a theory.
No, that's fact.
Yeah, it's
no,
not
I'm gonna tell you why
factual.
it's fact.
It
because-
is. It's factual. Just
No,
as
I'm
in-
gonna tell you why
I
it's
hope you
fact.
have a good day.
Because my
I'm
theory, can be recreated in any other vector. I can push this ball in any other direction using force, and the ball will always follow the direction of force. I can recreate that experiment.
Yes.
You cannot recreate gravity in a horizontal vector to do what
Gravity
it
in
does
a
free fall.
horizontal. What do you mean a horizontal?
So you're saying
on a plane?
Yeah, you're saying. Look, let me just explain it real quick. So this water, right, inside the container.
Yeah.
When it's not moving and it's at rest, it remains level, right?
Yeah.
But as soon as I apply a force in this direction, the water
Yeah,
displaces.
give me 1 minute.
Yeah.
Right? If I apply a force in this direction, the water displaces to the back.
Yeah.
Right? If I apply a force down, the water displaces to the top.
Yeah.
So there's always displacement of matter when there's acceleration, right? When you claim in free fall, in free fall there is no displacement. The water should go to the top, but it doesn't. People say, oh, it's because gravity is grabbing the water and the bottle together and accelerating them at the same rate. But that kind of force cannot be recreated in a horizontal vector because that would mean in order to accelerate this way, the water will have to remain level. So you need acceleration without displacement.
No.
Wait, so how does that prove your point at all?
That proves that there is no downwards pull of gravity.
But that's a sideways.
It actually.
Yeah,
it
that's what I'm
doesn't.
saying. My point is that horizontal acceleration shows that there's always displacement, right?
Yeah.
Even when I accelerate down, when I physically accelerate this down, the water goes up. In free fall, people are claiming this accelerates down, but there
And
is.
so does the water.
Yeah, the water goes down, but it doesn't get displaced to the top, which it should if it was being accelerated.
It's about a body of mass. It's not.
That's what I'm saying. Gravity claims that it grabs the water and the bottle and accelerates them at the same rate
Yes.
without any displacement. That kind of acceleration cannot be recreated in any other vector.
I can, yeah. I can get in a car and I can
Can you-
drive with my shirt on, and my shirt will stay on my
Can you
body.
accelerate this container without the water swishing? Without the water displacing?
Yeah, just go slow enough.
So sorry. I
No,
don't
but
wanna-
acceleration is increasing your speed every second. No, but do it in a horizontal vector. How
Yeah,
can you-
no, I know. But going down. So
There
the
is no
idea is
displacement.
that
I have experience on my channel where I show there is no displacement.
yeah, I'll check that out.
Yeah.
So the idea is that the water's coming down, and with the bottle,
Yes,
and
at the
since when
same
the
rate.
bottle's moving, it's at a different rate. And since the water's because you're accelerating the container.
Yeah.
So if you could have someone in there, okay. So say there was a ball in here, and we move this, the water's gonna go. You know, the ball. So instead of the water, we put a ball. The ball's gonna slide this way, right?
Yeah.
And then so if we do that, but we also accelerate the ball would slide that way.
But how can you accelerate both at the same time?
With two forces.
Well, how would
And
that
two
happen?
forces.
Well, if you had a-
recreating the two gravity acting on both
The
of
kind
them.
of
if you
force
had a
that
ball
the kind of force that you're
held right in the
pleading for,
middle,
real
right?
quick.
Taped or whatever in the middle.
Yeah, if it's
not gonna
taped.
move.
Yeah, if
Oh,
it's taped, obviously.
It's still accelerating.
But here's the
ball's
thing:
still
the kind of
accelerating,
force
is it
that you're pleading for is that somehow a force is able to grab the water molecules and glue them together to the bottle and then accelerate it without displacement.
It's not gluing them together. It's acting on every single molecule.
Yeah.
It's acting on the
Yeah,
water.
so
Yes,
that
it's
kind of-
acting on every object.
That kind of force cannot be recreated in a horizontal vector, pretty much. It cannot be recreated. That's why it's a theory.
Right. Well, no. If you have all that forces, if you have so take a magnet and then you have a bunch of other magnets. The magnets are acting on every single magnet, recreating just like that. The magnets are going to move. It's a bunch of forces. It's a bunch of different force vectors pulling it that way.
Yeah, but magnets only affect metal, first of all. But second, that kind of force, like a field that grabs everything together,
Yep.
that kind of force doesn't exist. That's my point.
Well,
Why does it matter that it
that's
only
where we
affects metal?
disagree.
It proves that it's
Well, because even if you have a metal container with water inside, the magnet, it's not gonna grab the water. It's only gonna grab the bottle, and then you're still gonna get displacement.
Yeah, but if you have metal water, if you have another metal object in here, then it would grab that too, and it would move.
Yeah, it probably would.
So that's because the metals act on only metals. What the idea of gravity is, it acts on all objects.
Matter.
Yes,
Yeah.
all mass.
That kind of force that can act on all matter, like a magnet, doesn't exist. I'm glad you're there.
But I can imagine it exists, and I can.
Sure, I can imagine it too. I can watch.
And I mean, I can imagine it exists, and I can theorize it. And it's very hard to disprove, and it's not disprovable.
A lot of things can be imagined and put into a cartoon, but doesn't mean it's real.
Yeah, that's not what I'm saying. I'm saying it can't be disproven.
Well, it could be disproven by the fact that there is no displacement. Accelerometers don't detect
No.
acceleration.
The idea that it's pulling all of the objects, you can't disprove that. At least not with any like backyard experiments.
I can, because accelerometers will always detect change. But so basically, in free fall, there's special pleating that's going on. So you're doing special.
No, I'm special pleading because it's a special force that acts on all masses.
Yeah, you see that contradicts every experiment here on Earth.
It does. It does not. How does it contradict every experiment?
Because
here on Earth?
that kind of force cannot.
We're talking about different forces here. This is the force of gravity versus the magnetic force.
Yeah, that's an imaginary force that you think is happening.
The magnetic force is imaginary too. We can't see it.
The magnetic force is not acting on matter in free fall. It's gravity in your model. My point is gravity. In specific is the imaginary force.
But why is the magnetic force not imaginary?
Because it can affect metal. We can test it and measure it. Gravity cannot.
We can't be sure that it's the magnetic force, though. We cannot be sure. There could be an invisible person just walking around and pulling all that stuff.
My point is, magnetic fields can be recreated and used. It's used in technology all the time, right?
Yeah. Gravity is used in a lot of technologies. We use it in like every single technology.
And if they use it, they're using the upwards push of the Earth. They're not using a downwards pull.
Because they would do the same thing. They're using either, depending on which one you believe in. Because you would say
but
gravity and the
only one
force.
can exist. That's the thing.
Right, exactly.
And it's the upwards push, the normal force.
And I disagree.
Fair enough. I'm not going to convince you.
Okay, I have to go get my ID.
All right, you guys on my channel. Yeah, appreciate it, man.
Thank
you guys take care, man. All right, have a good one. All right. Oh, damn. I got to go. Fuck. My, hopefully my parking doesn't fuck me. God damn it, what the fuck? Alright, it's gonna be it. Gotta go. Gotta go. What's up, man?
Love that.
Yeah.
I'm definitely not.
Trust me, you are. You are, though. You are. Alright, it's gonna be it. Thanks for everyone that showed up, everyone that supports, that watches the channel, that shares it. As always, thanks. I appreciate it. Yeah, it's gonna be it for this one. I gotta go. My parking expires. So yeah, see you guys on the next one. Peace.